So welcome everyone to this MicroStream fundamentals training. As you have noticed, we are recording this the entire 2 days training sessions, so that later on you get a link to that recording so that you can review certain parts again, of course, if that might be needed. I would like to give the word first to Marcus, because then he can give us a short overview and introduction, what MicroStream is, what the idea is about MicroStream. And then later on I can look over the agenda with everyone and what the goals are for these 2 days. So Marcus, go ahead.
Thank you, Rudy. Hello, everyone, and welcome to our online training, MicroStream Fundamentals. My name is Marcus Kett. I'm CEO and co-founder of MicroStream. And so we are working on MicroStream for almost 10 years. In this course, we're talking about how MicroStream works and how you are able to build ultra-fast memory database applications with MicroStream. Okay, with MicroStream, you can store your object graph, and by storing object graphs, and it also enables you to load any object graph and to load it into the memory and save your object graph without any object relational mapping. So this is what MicroStream actually is. It's open source. It can use it via Maven. You can load it and use it via Maven automatically. And MicroStream is also open source. It's very easy to use, and we also are integrated with Helidon, and we are also integrated with Micronaut, and MicroStream is also so we worked on MicroStream almost 10 years ago, and 2 years later, when we started with MicroStream, then we used MicroStream in practice and in production. And then around 8 years later, we found a company and built a company around the open source project and built an open source project. And now it's more than 1 year is open source, and yeah, now it's under EPL license, so you can use it for commercial purpose only, also open source, and also for yeah, building open source software, and also yeah, closed source software also. MicroStream also provides you large test coverage and update warranty, and also enterprise support. So the question is, why do we need micropersistence and for microservices actually? And the question is, traditional Java persistence is mostly very complex. It's often heavy byte, and through runtime, database applications are often very slow, and it's also often expensive through runtime, especially if you use traditional database applications in the cloud. And here we can see the architecture of traditional database applications. So we have really worked many years on object relational mapping. So we tried to improve it and accelerate object-oriented mapping. But the problem is that basically Java is completely object-oriented. It's type safe. Everything is very easy to implement. But as soon as we want to store data, then we mostly used to use traditional database systems like relational databases. And the challenge is that traditional databases they work completely different in comparison to Java. It's because storing complex object graph into traditional database is actually not possible. The reason is that the relational databases, they use tables, and it's not possible to store complex object graph into tables. And in practice, we use object relational mapping, and there are many impedance mismatches, like subtypes or data navigation, data types, they are different. So this is the reason why Java objects and traditional databases are actually incompatible. And the same problem is, or with modern NoSQL databases, we have the same challenges. It's because all of these databases, they have introduced their own proprietary data structure or formats, like com stores or JSON, XML, or graph databases, object-oriented databases. All of these databases, they have their own proprietary data structure or format, and so they are also incompatible with Java object graphs. And in practice, we have actually the same challenges. And to solve this problem, we need an object relational mapping if we use a relational database, or a data conversion if you use a NoSQL database. And we need this object relational mapping or data conversion through every single read and write. And this leads to many challenges, like so we need more CPU power, or we need cache, local cache. So the complexity increases more and more. And to accelerate queries, mostly we use local cache to accelerate queries, and so the application becomes more and more complex. In practice, mostly applications are built as distributed applications, and so this can be a problem. For instance, if you change data in your application, the node then is in sync with the database. However, all of the other nodes are not in sync with the database. So this is really a problem. And in practice, mostly you can use a cache between the application and your database. And to avoid a single point of failure, mostly you can use a distributed cache. So the architecture gets more and more complex in practice. We don't and we use more and more CPU power, more and more machines, and the cost of infrastructure are increasing more and more. And if the loads also increases, then mostly we need a database cluster as well. So we need additional machines, additional CPU power, and so the architecture gets more and more complex. And so this is a traditional architecture, and it's a common architecture. But we believe Java in-memory data processing is much more, it's much faster, it's much more effective and easier to implement. And also in-memory computing is much faster. It's because of using in-memory database is up to 100x faster, sometimes up to 1000x faster when we use in-memory computing. And with Java, Java is super fast. So if you use Java in-memory data processing with pure Java, then your application is much faster, up to 1000x faster if you use Java in-memory computing. Java is very powerful, and it allows you to use object graph model. You have the best data structure. So the database vendors, they are still looking for the best data structure, and Java provides the best data structure from the beginning. It's object graphs. So with an object graph, you can build your object model freely. You can use you can use any object. You can use lists, or you can use circular references, whatever you like. And for searching and filtering, Java provides JavaStreams API. So with JavaStreams, you can search even complex object graphs in memory in microseconds. So even if you have if you search and filter complex object graphs in memory, you have gigabytes of in memory. It takes only microseconds. And so searching object graphs in memory with core Java, with Streams API, it's extremely fast. So Java provides a great data structure, Java object graph, and provides a great query language, Java Streams API. And we talk about microsecond query time. And traditional database applications, traditional databases, they provide you they provide not microsecond query time, they provide millisecond query time. And this pure Java, we have microsecond query time. The only thing missing is a function to store object graphs and reloading object graphs and restore object graphs in memory when needed. And MicroStream follows the system prevalence pattern. And the system prevalence concept is really simple. So just keep your data in memory, just use plain objects. And if you change objects, then just store your objects persistently on disk by creating snapshots. So this is a very simple concept. And MicroStream follows the system prevalence concept, but we don't create a snapshot of the entire system state. We just store the delta, just changes are stored persistently on disk, and vice versa. When we load object references, then you can load only object references that are needed, and MicroStream loads only object references that are needed on demand. So we don't load the entire database, just load the object references. So how does it work in practice? Let's have a look on how the database servers concept works. So we have an application or a microservice written in Java. You have your objects in memory, you have object relational mapping or a data conversion, local cache. And then let's have a look how the database applications or databases work. So under the hood, the database systems, they also have storage data. They store data as sometimes as binary data, or sometimes human readable format. It depends on which database system you use. The database system provides you caching, and the database is cared for locking, and enables you to use store procedures, store functions. So this is the functional principle of a database server. And with MicroStream, we now replace object relational mapping or data conversion by using MicroStream. So we don't need object relational mapping or data conversion anymore. We use the object graph in memory as an in-memory database. And so your data or your objects are in memory already, which means we don't need a local cache anymore. Then we also don't need a database management system anymore. We don't need a server, a database server, because we use the object graph in memory as a memory database. So we don't need a database server anymore. The only thing we need is the binary data and in a data storage. So the end result is a super simple architecture, plain Java, and we can use any kind of data storage. With MicroStream, you can use plain file storage, but we also provide storage connectors to all important database systems. So you can also use a relational database like PostgreSQL. You can use a blob storage like AWS S3. But it's very important to mention that we store binary data. So you can use all database systems that are able to store binary data, and so it's we are recommended to use blob storage like AWS S3 because they're built to store binary data. It's very easy to use MicroStream. It's core Java. There are no requirements. The only requirement is actually Java version 8. It runs on container. It runs in the cloud in container. So also you can use it with Gravian native images, and we have implementation that runs on Android. MicroStream is not only serialization. So serialization is a core feature, and we don't use the Java serialization, the standard Java serialization. We have built serialization framework from scratch. It's because of we are able to use complex object graphs, so there are no limits. You can use all Java types, and it's much faster than traditional Java serialization. So we have MicroStream serialization from scratch. Then we have a persistence layer for server-side applications written in Java, and we have an implementation for Android. And on top of that, we also provide various services like legacy type mapping. So, which means what happens if your classes change? So MicroStream cares for your legacy types. We added file system garbage collector. We added a file system abstraction, database connectors, a REST interface that enables you to get access to your storage data. And on top of the REST interface, we have a storage browser that allows you to browse your storage data. We have native backup functions because you can use plain files to store your binary data, and then MicroStream provides you native backup functions, or you use a database system, then you can use backup functions of the database system. And we also provide a converter like CSV to import data, to export data, to migrate data. We are also working on distributed applications with MicroStream. And all of these functions, this is MicroStream, and it's open source. So as I mentioned, we are working on distributed applications. And here is the architecture again. So traditional database application with Java, 3 layers, three clusters, and so you need many machines and high cloud costs. So now we can replace traditional applications or microservices with MicroStream distributed applications or services. And if you have 10 or 20 traditional applications and machines, then you run MicroStream, then perhaps you need only one machine and you have the same power, so you can save lots of machines and cost of infrastructure. Then you have a distributed application. We use the online, we use the object graph in memory as in-memory database, which means all data are in memory already. So we don't need a local cache anymore. Then we are able to replicate the object graph through 100 or even 1,000 of JVM nodes, which means we don't need a local cache anymore, and we don't need a distributed cache anymore. We store the binary data in plain files or in a blob storage, which means we don't need a database cluster anymore. And yeah, as I mentioned, we don't need a distributed cache anymore. So we save lots of machines and lots of cost of infrastructure. we have customers, they save up to 90% of infrastructure. Here's a comparison, traditional cluster and a MicroStream cluster. Okay, so how does it work? If you have a look on the code, so it's very simple to use MicroStream. The code is simple because there are no requirements to your classes. So you just use plain Java objects. There are no interfaces to implement. There are no annotations needed. There are no superclasses. Just plain Java objects. No requirements to your classes. Then how should you design your object model? That's a good question. You can design your object model completely freely. So whatever you design, MicroStream will be able to store it. You can store simple lists. You can use circular references, so that everything you design with MicroStream, you can store it with MicroStream. The only thing you need is a MicroStream instance. So what does this mean? You just need a MicroStream instance and create a root object. And you have to define your storage, an instance of your storage. You can create a storage. You can use plain files. You can use blob store. And then every object that is added to your root object is reachable, can be stored by MicroStream. So you just have to add some new objects and then just call a store method, and MicroStream will be able to store your objects persistently on disk by calling only one root object. And each store is transaction safe. So let's add some objects here. And then you store the root object. And then MicroStream will store the binary data persistently on disk. So on each store will be create a new storage file in your file storage. So you can add some more objects, store the objects, and MicroStream will store only the changes. So we will never create a snapshot of the entire system state, but we only store the changes. Only the deltas are stored persistently on disk. So we create more and more binary files in the storage. If we change objects, as I mentioned already, we change the object reference, we store the object again, and MicroStream stores a new binary data persistently on disk. So also the changes are stored persistently on disk. New object, changed objects, and so on. Initial system start. So if you start an application or microservice initially, MicroStream loads the object graph in memory, but only the object IDs are loaded into the memory. If you don't use lazy loading, MicroStream loads data as well. But if you use lazy loading only, then MicroStream loads only the object IDs into the memory, but no data. So if you call a get method, let's say call get customer, then MicroStream loads the object reference into the memory, loads the data, and merges the data, your object, directly into the object graph. So just call a get method. There are no more classic selects. If you use lazy loading, so if you use if you don't use if you just use the objects, then MicroStream uses eager loading and loads the data. If you use lazy loading, then MicroStream loads data on demand only. And we recommend to use lazy loading. It depends on your use case. If you have a small database, if you have enough memory, you can load all data into the memory. And if startup time is not that necessary or not that important, then you can load all data into the memory. If you use microservices, then startup time is very important. Then it's recommended to use lazy loading, load data only on demand. So just call get method, then with lazy loading, I can load the objects into the memory and so on. So then just call get methods, and MicroStream loads object references. And it cares for memory management. You don't have to care for memory management. Everything is done by MicroStream behind the scenes. You have fully control of your lazy references. So you can delete your remove your lazy references and clear the lazy references to save memory. And if you don't clear your lazy references, then MicroStream will care for it automatically, so that you don't run out of memory. Then MicroStream cares for memory management. If you want to search your object graph in memory, just use JavaStream's API. Even if you have, if you search complex object graphs in memory, it takes only microseconds with JavaStreams. And so if you have, if you want to search and filter really huge collections, then we are currently working on pageable collections. Then with the upcoming version of MicroStream, we will launch the pageable collections, and it allows you to search even millions of objects very easily. So what happens if your classes change? Then with MicroStream, we provide a legacy type, so-called legacy type mapping. So if MicroStream loads an object into the memory, then it compares your object with your class. And if you have changed your class, for instance, you have you add some fields, you rename a field, or you change data type, primitive types, then MicroStream solves this issue automatically behind the scenes by a heuristic. And if there are more complex changes like objects, then you can define so-called legacy type mapping. After you change your class and MicroStream loads an object, then it executes the legacy type mapping. Then you have to change you have to store your object again, and MicroStream stores the latest object as a binary file into your file storage. Then you have two versions of your object in your storage. It's the previous version of your object, and you have the latest object in your file storage. And by using the MicroStream garbage collector, it removes your legacy objects from your storage behind the scenes automatically. So with this garbage collection, it removes the legacy object from your file storage and keeps your storage and cleans up your storage all the time behind the scenes. This is a functional principle. MicroStream is a paradigm shift in database programming, and this is very important to mention that here we have on the left side the traditional database server paradigm. Here we have a database server. It runs remotely on a remote machine. The database is located at the remote machine. The queries are executed on a remote machine. This is the traditional database server paradigm. With MicroStream on the right side, your database is located in memory, is located within the same JVM process of your application or microservice. So your data are really close to your application. This is your in-memory database. And queries are executed in memory. And this is the reason why MicroStream is so fast. So it's because we search object graphs with streams. They are executed in microseconds. And only the storage data are located anywhere. So you can choose where your file storage is located. As mentioned, you can use blob storage for that. So this is a paradigm shift in database programming. So you have to think a little bit different. Just forget everything you have heard about classic databases. Just think about object-oriented programming. Just think like a like a Java programmer. Very important to mention again. You have lazy loading, which means if you have enough memory and you have a small database, yes, you can load your entire database into the memory. Then your application will be super fast. But it depends on the use case. If you have a monolithic application and you run your application once and you start your application once and you run it for 2 years, then this is a great concept. You can do that. But if you want to build microservices, perhaps you need fast startup time, then this is not the right way to go. Then you need lazy loading. And also if you have a big storage size, if you have a big database and you have only a small memory size available, then don't use eager loading, don't load all the data into the memory initially. Just use lazy loading, then you have a fast startup time and load object references just on demand. Then you also can run and use big database size and small memories. So it depends on your use case. You can do really both. That is actually a functional principle. And yeah, Rudy will now jump in the code and show you how to get started with MicroStream. If you have any questions, yeah, you can make a little Q&A and try to answer the questions.
Yes, thank you, Marcus. There were already a few questions that I answered in the chat, but everything or almost everything that you mentioned here will be covered more in detail today and tomorrow. So that's a reassurance, I guess, that if people have questions, they can still ask it the next hours or day or so. But yes, if you have some high-level general question about MicroStream for Marcus, maybe you can ask it now.
Yeah. So MicroStream serialization in comparison to existing serialization implementation like Creo. MicroStream is built to store any kind of object graph, any size, any complexity. So with MicroStream, there is no there are no annotations, there are no interfaces, so you don't have to implement serializable, no requirements to your classes, and it's built to store any complexity. So you can the depth of your object graph is not limited. So this is only possible with MicroStream serialization. Additionally, it's highly secure. With MicroStream, we have a fundamental different principle, so that MicroStream is really safe. So we don't injecting malicious code and executing malicious code through deserialization is not possible with MicroStream. So this is perhaps through the training we can jump a little bit into deep how the functional principle works, but it's also security, and it's faster than existing serialization. This is the reason why we developed serialization from scratch. Can several application instances access the same object store in parallel? MicroStream as it is a single node storage, but we're going to introduce MicroStream replication, and this enables you to build distributed apps and microservices. And then with this solution, it's possible to run multiple instances of your service or application that access to your object storage. Yes, currently, Rudy answered this question already. Okay, the in-memory footprint of the object ID graph itself. When you start your application initially, then MicroStream needs a little memory. It's because of we have an object registry, so we need some more memory for creating the objects in memory, and MicroStream loads also some data into the cache if this is possible. I cannot say how much memory do you exactly need, but you don't. As you need some memory, of course. It's because so we want to use in-memory data processing. So you should have some more memory, and it's also recommended. And so we save lots of CPU power, lots of machines, and save cloud costs, so that you can invest into memory and use the in-memory data processing with Java. So it's really recommended to use in-memory data processing.
Yeah, I replied there that for each object that we load, we keep a pointer also, an additional pointer, for two reasons. For see if it's changed, more on that later this afternoon. And also then to keep the structure of your object, etc. So at the minimum, there is some other small overhead, but at the minimum, we for each object that we keep an additional pointer. So thank you for your intro, Marcus. I moved it a few minutes before because there was also a question about agenda and time scales, but I know you have other things to do this evening, so that's why that's why I wanted to have your intro as quickly as possible, as soon as possible, so that you can go to your next task.
Thank you very much. It was a pleasure to join. Thank you. Bye.
Thank you. So you should be able to see my screen now. So then, yeah, first a few administrative slides, but you know already Marcus, he gave the presentation. So I'm Rudy Busscher. I'm working as developer advocate for MicroStream. And I will give you this training at today and tomorrow. I will talk a lot because I have prepared a lot of examples. I've prepared a lot of slides with explanation how things works, etc. But feel free to interrupt me on chat, but it might be the case that I not always see the chat. You can also unmute yourself and then ask me the question, of course, directly. That's not a problem. We are with quite some people, so that's a good thing. But of course, with the hands-on that we have later on, for instance, the exercise this afternoon, it might be the case that if a lot of people have questions and issues, then I will not be able to help everyone in a timely manner, of course, but let's see how it goes this afternoon. So 2 days, day one, we have had already the introduction, and basically the idea is that all the topics that were mentioned by Marcus, that I'll go into them into detail. From setting up your project, how to read, how to write data, and all those kind of things. And so lazy loading, the legacy type mapping, the backup and fallback strategy, that was also a question. So that's all covered. Normally tomorrow afternoon, we have a bit of time that can be used for any kind of questions that come up during these 2 days and cannot be handled immediately. So if it takes a bit of preparation from my side, for example, to give you a proper answer or so, or it takes more time to explain it in detail, to answer the question in detail, then we have something like 1 or 2 hours tomorrow afternoon. Things that already came up in the previous trainings is that, for instance, how to write data to Azure Storage Blob, or how to use a database, etc. Those are examples there, but as mentioned, if you have any kind of questions, then we can address that at that moment. There is also a question from RD records available for later. Yes, that's why this is recorded. The entire sessions are recorded. You get a link to that recording later on. There will be some kind of processing going on. For instance, they try to remove as much of the empty spaces. I try to stop and start it, the recording at the appropriate times, but there is some processing done, so it can be that it is only next week or so that you get the link, but in any case you get a link, and you will also have a link for the examples to the GitHub repo. So that's day one and day two, so that you have a rough idea. Yeah, so day one is going from 0 to 100, I would say. So all the things that you need to have in place to get it started. They too are more smaller little topics, more isolated, but are also important things like the lazy loading, the legacy type mapping, etc. And a quick recap of the Java 8 Streams API.
This is Michael Rudlick from New Jersey. How are you today?
Good.
Good, good. So I am here today because I'd like to learn more about MicroStream, and I'm also putting together a Helidon fundamentals course that will be through MicroStream. So I want to be able to give a 1-hour introduction in this upcoming course.
So you need the basics to get it in your training yourself.
Yes.
Okay, good. I see that someone put it in the chat, so I will mention that. So he mentioned that he wants to learn all about MicroStream. He works at the San Diego Supercomputer Center and had to deal with tons of data, specifically the RCSB, PDB, aka rcb.org, a protein databank. So, yeah, good to hear that there is interest in that, and especially then that lazy loading of tomorrow, where we handle large data sets. Then that will be probably the most interesting part for you. Someone else says that he does not have a mic, but I hear a lot from MicroStream in Java user group, so I'm interested in learning how to use it and maybe how to replace my database for smaller applications. So yeah, good. Anyone else who wants to speak up? Uwe is mentioning in the chat that he is considering MicroStream integration as a projection implementation option into a event sourcing based framework. So do I understand it correctly that you are trying to store the data from that event sourcing then through that through MicroStream, or is it complementary? Yes, so storing the data of the event sourcing itself. Yeah. Someone else mentioned that he has a Java and business intelligence ETL background and is thinking about to use it for a new solution in the field of the ETL processing, business intelligence and process mining. Nice, nice ideas. Out of the area that we are thinking always, where you can use MicroStream, but actually there is no limitations where or how you can use it, as long as it is in Java. So yeah. And Michael also mentioned that he wants to use MicroStream for his own purposes, for his own applications. So anyone else, or do we continue? There is someone now planning a read-only mirror of our legacy slow property software for fast queries. Yeah, indeed, that's one of the use cases that we have also in mind, which is not explicitly mentioned. So maybe I go quickly over the 3 main use cases that we see for MicroStream. And indeed, one of them is the caching functionality in a microservice environment, or as you have the idea to have caching for slow proprietary software. But the idea is that with microservices, you have today a lot of, probably a lot of microservices. And the question is then, of course, do you need them? But that's another question. And instead of going to look for all the data every time for each request, then you have a local cache. That's something which is more or less given these days, but if you have that local cache with MicroStream, then of course you have already a hot cache. All the data is available immediately when your microservice starts up, because yeah, he reads the data from where it left off. So that's one of the use cases. The second use case that we see most fitted is for those that do Android development, for the offline storage first strategy, when your application and your device does not have always internet access. Instead of using a database there, then to store it on the device storage medium, you can use then MicroStream there. And the third one is then also with the serverless functionality, where in the case you use mainly the lazy loading, so that when your serverless function can start up quickly, not loading all the data, but only a minimal required set, and then loading the data, what is needed for handling that request based on the request what's coming in. That can then be much faster than accessing a database, and cheaper because your database in the cloud will be running all the time, which then consumes money. So that's the three use cases that we see most suitable, but as I mentioned, it's up to your imagination and the limits of your imagination, what you can do with it. Someone mentioned here also that we are also using it, using some caching layer in memory, and I was curious to see if we could use MicroStream for that. So the one JVM one data store rule might prevent it though, but as I mentioned, that's a restriction of the open source. There is also the enterprise version where that's not the case, which we are working on, which will be released very soon. So everything, every example that I will cover today and tomorrow is in this GitHub repository. I put it also in the chat, the link, so that it's, and then you don't need to type it over. So all those examples are there, and the slides at the PDF with the slides here is this one, the MicroStream fundamentals training.pdf. It should be, yes. So then you can also review that, and as mentioned, you have access to the recording later. We are using Java 11, although, as Marcus said, the current limitation of the MicroStream version 7, which is the latest, that 7.1 is the latest release, is 1.8, but I assume that most of you have already Java 11 available. If not, every example should also work on Java 8. There I'm not using anything specific from the newer versions, but the Maven project files that I have prepared and which are also in that GitHub repo, they define by default that you have the JDK 11 version as source and target. And of course, you should use any IDE. Question is if it's also Java 17 compatible. Yes, there it is, Java 17 compatible. For some newer constructs in the JVM, like there are some special collection types there, you need an additional handler, but more on that than at that moment when I mentioned that that's probably best when I do the legacy type handling tomorrow, because it's also about specific handlers. So I'm making a note here so that I cover what you need to do so that everything is handled from JDK 17, but a standard list, hash map, strings, and all those things nothing specific is required for JDK 17. The timetable is here also mentioned. So the idea was it was between 10 and 5 Central Time, US time. You have to recalculate because we saw already that several people from other countries joined, including Europe and Africa. So then you have to do a little recalculations, but there is also a break. That's known, I will say at noon, but of course, for some people it's not known, including me, because I'm from Belgium, if you're wondering. So it will be late also for me this evening. And as I mentioned, please ask questions. People are using the chat, but also feel free to interrupt me if needed. Maybe a few quick things before I dive in more code, because the idea is that, of course, that I explain a lot based on code. But the classic flow of how you or especially in this training, how we are going to use the MicroStream framework, because it will be mostly with Java SE, so just the public static void main method, because that's the easiest thing. We will cover also a bit of using it in a web application, etc. But if possible, I try to avoid that because it's just much easier if you don't have that overhead of a runtime for handling web or REST calls, for example. So of course we need to start with the configuration, and that's something MicroStream related. That's why there is the MicroStream logo, and that's something what the developer needs to do. So it is in orange. So the developer needs to, of course, do the configuration. You can compare that with something similar to setting up your JDBC connection. I'm going always to make, or most of the time, make the relation with how to use it with a database, how you're using database, because I assume that most of you are familiar with working with databases. So then you know the counterpart of it in MicroStream. Another thing which is important, and once it is configured at the storage manager, we'll go to that in more in detail, but the storage manager needs to be started. That meaning that it reads the data, which are stored, that binary data, so that you have your initial data in memory again, and that you're also able to save changes. So don't forget to start your storage manager. Again, something that the developer needs to do with some integrations. I mentioned briefly that we have those integrations, for instance, for Spring Boot, Quarkus, or Helidon, Micronaut, etc. Sometimes that's done by the system itself. But normally you, as a developer, start the storage manager yourself. Then there is a bit of MicroStream magic happening. The blue block, which is loading that object graph. As I mentioned, when the storage manager starts, it loads or it examines the data in that storage, that external storage, in that binary format, and then it decides what it is loading already. There, I must admit, there is some magic happening. I will show you a few of those things that you need to know, because it is not standard Java what's there happening. For instance, we are not using the constructor to instantiate objects. So there are a few things which are a bit different than standard Java. Then in pure Java, we query, you can query your data, pure in Java objects. And the idea is that you just launch a stream API or using a getter method or whatever is appropriate for your case, that you read the data, which is then in memory or will be loaded in memory when you exit it automatically with that lazy data, and then you have your results. So we are not writing SQL queries, so we don't write select address from customer where customer country is US, for instance, and we don't do that. It's just a query using that streams API. And yeah, if you make changes, then not for the sake of having the data saved. I mean, when you update an object in memory, it is already changed in your database. More on that is in the advanced course, as we have also an advanced course where we have strategies around rollback and concurrency, etc. But if you have changed the data in memory, then actually you have changed your data in your database. But yeah, if your process dies at that moment, then it's not saved to the external storage. So you need also to save the data, which is initially initiated by the developer. That's the yellow part of that last block. But again, it ends with a bit of MicroStream magic, although this is less magical. It is just that serialization, which was is what you already mentioned and which I can go into more detail later on. So that's something that you need to keep in mind. But then, first of all, I would like to show you why you might want to drop your external data storage as primary source, also like a database. This is more or less one of the slides that you already saw in the introduction of Marcus, where you always have the difference between how data is stored within your Java program, within the JVM, as Java objects, as instances, as a object graph, and externally where it is stored in tables and fields, or in a column type of storage with NoSQL, or even in a distributed cache key value or whatever. You always have that mapping and that data conversion, which can be a quite large block. So, for instance, the probably most known one is Hibernate. And with the example that I'm going to give, you will see that it is not a great job what Hibernate does, but in general, Hibernate does a good job. But because that conversion from your object to that external database, in the case with Hibernate, can be sometimes so complex, or the developer can start writing so complex queries that, yeah, it becomes quite difficult for Hibernate to know what it exactly needs to do. And it makes sometimes a few mistakes, like I will show you in the example. And that means that when you are testing your application, you need to test it properly. You need to debug it. You need to dive into that object relational mapping. You probably will need to help Hibernate a lot with that eager and lazy loading indication, the joint fetch statements, etc., to help Hibernate to make the correct queries for you. That can be quite some task. That can be you need to learn a lot about Hibernate. There is a lot of, available as functionality within Hibernate, which is good, but it's a large learning curve. With MicroStream, it's all pure Java with a few things that you need to know. So that's in that case is much easier. And yeah, you know, data is everywhere. Probably we don't have any need for a enterprise application, let's say, if you don't have to manage some data. So data is the gold for many companies. It's their main asset. It's what makes the company profitable, which makes that the company can survive, because they have all the data. They can process the data, be it some order processing in a web shop, or follow up in a manufacturing environment for customers, etc., or data and analysis on the data for IoT, automotive, or whatever. In my presentations, I always mention then that there are about 350 different solutions to store your data externally. So you see there is a wide variety, but actually none of them use the Java object, the Java way of working as a native storage capability. We are the only one, so that makes then that you can reduce that large block in that previous. I can go back easily. That makes that this orange block, that data conversion object relational mapping can be much smaller and easier with MicroStream. So what is my performance demo? The data model looks like this. It is about a bookstore. So we have a company which owns several stores in several countries. And for each store, we keep a track of the number of purchases done by people, so that are the customers. And each customer has then, of course, an address and city, state, and country. We keep them through that card. So if you show your how it's called, not confidential, or I'm missing the English word for the moment, but you have your membership card or whatever, then we know who you are and who bought the book. But each shop, of course, has also an inventory, what is available within all the books that are available, and we have the author and the publisher of each of all of these books. So it's not that complicated. Probably most applications that you're working with have a much, at least a much larger, but also a more complex data model. But you will see in our example here that even Hibernate can make a mistake there, and it's quite slow. And I realize now that I have stopped my database, so I'll need to start that over again. So let's do that first. And in the meantime, I explain what is available there. And it is also this one of the examples there in that GitHub repo, so you can play around with it yourself and see what it is doing in more detail. So we have actually the same data, which is in a database and a Postgres database, and that we access through Hibernate. And we have also the data here available in that binary format of MicroStream, which you will learn all about today and tomorrow, about the details, and that we have here those channels with all the data here. I'm going to try to open the data, but of course it's binary and it's not much, you cannot make much sense out of it in this format, of course. It's a simple Java program, so I can just run the main method and I open a session with Hibernate to the database. So that's defined here in the configuration. So I define it as the database where the database is and how to access, etc. And the question is, what I want to answer is, give me all the purchases of foreigners. It's not actually foreigners. Actually, I want to know from that data model, I want to know when a customer lived in another city than the city of the shop. And I want to know how many purchases and the details of those purchases made by those customers. So not that exotic. So if we go down, then we see that we need something like this as a query. So I'll want to have the information about the purchase. The purchase entity is keeping track of the purchase itself. Let's have a look. What is it? What it is? So it is. It has a link to the person at within the shop who made the bill, the customer, the timestamp, and then a list of the books and the amount of books that that he or she bought. But to have this criteria that it needs to be another city than of the customer than the shop, I need, of course, to load a lot of things. So from the purchase entity, I need to know the shop, joint fetch it with the address, the city, the state, and the country, because I need to have it for a certain country. Same for the purchase for the customer. I need to get the data. And I want to have a list of all the books that they bought. So I joint fetch it up until the book one. So you see, I did not count them up front, but I guess I'm joining like 8 or 9 tables. Is it then I need to start the database. So this is running now. So I'm executing this query for a certain country and a certain year. So I have about 300,000 purchases there, to 30 shops. So it is not that large database. It's not a Hello World one, but it's not with millions and millions of records. It is about around 10 megabytes of data in total or something. And my query took 1 second and 14 milliseconds. So that's not including the connection to the database and initialize Hibernate. That's here. It's the database access itself. So I'm try to have here using a stopwatch to see how much time that the Hibernate itself needs to initialize. The first time with the database, that itself took 2.3 seconds. But then my query took more than 1 second. The second time, of course, everything is loaded, then it is much faster, 115 milliseconds. But that's because everything is already in my secondary level cache. And actually, if you are having a specification like JPA or Hibernate, which is following in that, which says that, oh, we need 2 caches to make sure it works efficiently, then yeah, you probably know that performance might be an issue when you are using those kind of things. So the first time it takes more than 1 second, then you're asking yourself, how is that possible that a query, okay, it's 10 tables, but I thought that I was doing a good job by saying that he is making joint fetches so that he only executes one query to the database and not multiples. Why is it then possible that it takes so long? So then you need to dig into, of course, into statistics, show SQLs, etc. That you probably all know to get your data to explain what Kubernetes do. There is the question that's only comparison on execution time. Is there a comparison on used memory by the JVM? No, that's an interesting thing. I should add that probably in the next version. Although getting how much memory is used by the JVM at a certain point, you always need to heap them and do some calculations, etc. So it's not always easy to find out what exactly the amount of memory is used by a certain object graph or process, because you have those at a garbage collector which works independently and you cannot manipulate. Now with my statistics enabled, I see that it performs 342 JDBC statements. Wow, I was thinking that I was only having 1 or 2, not 300. What is going on? Every query that he performs is listed here. So what you see, he always selects the author. So somewhere he's selecting the author. If we go back to our query, then, well, we don't ask for the author. So what is he doing? Well, actually, the idea was that I had a book here. And of course, a book without its author is not very meaningful. So the idea was, hey, let's have an eager fetch type here. That's perfectly fine, because then it should fetch it eagerly within the same query, but apparently not. My query is already that complex that Hibernate is unable to do what I need to do there. So what's then the solution here? Although I basically just want my books, I need another joint fetch where I join the author within my query. If we run this time, then we see that, of course, we have found a problem. But that's because I knew what the problem was. But if you don't know it, then it can take some time to find out why he took 340 JDBC queries. Now it's only taking 6 of them, because yeah, actually there is also the same problem for the language. But okay, let's say this is manageable, that it performs 6 queries, and to have a proper timing to compare it with MicroStream. Let's remove again the statistics, etc., so that it does not spend some time there. And then we go from 1.2 second or something. We go up to 481 milliseconds, which is nice. Good job. But why didn't he do it immediately? The second time, yeah, he does not need to perform those JDBC queries. So the hot run, as I called it here, is more or less the same. So let's keep that one in mind. We cannot go below, let's say, around 150 milliseconds for our query. And that then, of course, is then because we have all the data already in our JVM, because it's using that secondary level cache. I have the same data here. So if you look here, the README, there is described how the data is automatically generated and how it is then first stored here as a MicroStream binary set and then uploaded into the database. So the data should be identical. So that's just so that I can compare more or less the same thing. And what I mentioned, the steps that we need to do, we need to configure that store manager that says, well, create me a link between this directory here, this bookstore, which is located here, and what we call a root object. A root object is a pure Java class, which is one of the possible entry points of our object graph, because most of the time it's not always wanted, but you cannot maybe avoid it, that you have circular references, which is also the case here. So this is just one entry point of your object graph, which keeps a list of books, shops, etc. And once we run this method here, which is, and don't worry about what is here, that's the configuration in detail. I'm coming to that later. As I mentioned, don't forget to start it. So then we have a storage manager, and this start will make sure that the binary data is analyzed, and actually these array lists are not empty array lists anymore at that moment, but actually are filled with data. That magic that I mentioned, which is happening behind the scenes. So the structure is the same. We also do some timings, and we perform here the same query, but now, and it is not written in the most comprehensible way, in that sense that we are using a lot of Java 8 streams, lambdas, etc. for computing, and what needs to be done once we have a list, because you can do whatever kind of aggregation or handling of the results of your records. You can do a count, you can do a group by or whatever. So here we just list them, and then we list them for a certain year in country, and then we have a predicate for a certain shop, etc., and those things. So, but basically this is, for instance, pure Java saying that a certain shop, the address is equals or different. Here we are, you see, we are using it as a different one for the address. For here we are using it to find a certain, all the shops in a certain country. You can have a look at it in detail. It does exactly the same thing. It gives you exactly the same amount of records back. And the first time, it takes only 110 milliseconds. That's already smaller than the 150, that's for sure. And moreover, those, going back to that root, where is our root? Here is our root. Those purchases, which I come back, they are what's called lazy loaded. So all the purchases that are made ever in those shops are not loaded by default in memory. So to make it a bit fair with Hibernate, it was done for that reason, so that it also needs to load the data for a certain year. They are, it's kind of an indexing, more on indexing later on, It's kind of indexing so that you don't need to load all the data all the time. So we index the purchases by year here, and then we load them for a certain year, even with that loading. So at the moment that we access this value, is looping over the entire binary data set and finds all the entries. Well, it does not need to search because they are all already there through pointers, because we store pointers in that binary form. But it's loading actually then the data from this binary, and even then it is faster at the first time with the loading. Look at the second time when everything is in memory, and that's is no surprise. It's less than 1 millisecond because everything is already in memory, and your data is of course accessed instantly. And the only thing that needs to be executed is those stream APIs, those lambdas, etc. So actually, you need to compare this with 150 milliseconds of Hibernate with the second run, and this 110 with that 480 or something it was for the first query when it loads the data. So that's what you can achieve. Is this something exceptional? No. It of course depends on your data sets, how you have organized your data, and your data model. As the definition of your data model here with the data root becomes more important. So that's one of the topics that we will handle next. But it's not exceptional to see a change, a faster execution of your queries 100 times, 1,000 times. We have several cases. We have tried to come up with things where it could be slower, but it was always faster. Also inserting, there is a performance white paper. So if you're interested, we can send that to you. That also indicates that also storing data is much faster, mainly because you have three things. You have that external storage, so you have the latency to go to that other system. You have the data conversion that needs to be done, but also, for instance, when you store some entry in the database, for instance, it checks that the unique key, the primary key is unique. So therefore, we did an experiment with 3 million records, inserting it into the database and compared it with pure storing it in a binary format. Then, of course, the database takes much more time. So that those checking is, of course, required of that uniqueness of primary key, but most of the time you have done it already in your Java. So the database is doing it again, which is not really necessary and slows down the entire process. Are there any questions about this example between MicroStream and Hibernate? And then for the rest of the day, we dive into the details with some other examples, but in the details of how this MicroStream query works with the config and retrieval, etc. And I'll make a note so that I research later a bit about the memory usage difference, although that will be a tough one to have it correctly. So I hope everyone is back. And as I mentioned, the next one is the data model. First, in graphics, what that comparison, that performance comparison was. So if you would see there on the left that the Hibernate versus MicroStream. The initial setup of the connection to the database, initialization of Hibernate, took about as much time as loading MicroStream, the storage manager. But it means that all the non-lazy data are already in memory, so it looks like a lot of time, which is quite some time, but after that all the data is available, which means then that the query time can be much faster. You see here a bit different numbers. For instance, that Hibernate query took only 727 milliseconds instead of 1.2 seconds. That's because of the different setup. Now I was doing screen sharing and all other kind of things, which of course makes it slower. But you see the Hibernate one was 10 times slower the first time. And when we run it this second time, then we see that the query in Hibernate took about 87 milliseconds corrected with that joint fetch for that author, and the MicroStream one was about half of a millisecond. So that means that you have a factor of 150 roughly of time difference between the two ways of loading the data. Marcus also showed this, and that's pure of that difference is mainly, not pure, but mainly because of your external system. Not for the second time, of course, because what I mentioned, it is already then in memory, but Hibernate needs to analyze your query, needs to load the data from the cache, etc., which of course still takes more time than just accessing your objects like we did with that Stream API. Yeah, that's to mention, instead of having the specific format of databases, NoSQL solutions, distributed cache, event streaming even, each of them has their own format. There are sometimes good reasons for it, like for instance your graph database. You have specific functionality in the graph database like path traversal functions, which are extremely easy and useful to use. But most of the time, in most cases, people use their database as just as a dumping ground for their data. And that means that you need to do that data conversion, that object relational mapping, just to have it stored there, but not much using the functionality in most cases of that system itself. And then you have that overheads that we mentioned, of course, and with MicroStream, that's much smaller functionality that you need to learn, and that orange block which was quite large. With MicroStream, it is much taller. In fact, after today, you have already learned about 80% of all what you need to know about the MicroStream and how you can use it. So that's much easier than a complete Hibernate course. And then you store in that external system your object graph in a binary format, but your object graph of Java itself. So that's the main difference. You still have then probably that latency somewhere, but because you're again stored in an external system, but it is much faster and easier to use still at that point. The break we had already, so what was mentioned in the introduction of Marcus, and what also mentioned is that you need a proper data model, because your data model is now very important for accessing your data. It also will indicate how you can access your data or not. So you will see more in detail what I mean in a moment. So first of all, you probably know that, but just so that everyone is on the same level, there are some important differences, of course, between a relational model and a graph model, a object model within your JVM, what you're using within Java. A few words about how you can do bidirectional, which is not actually possible. For instance, with the standard database, there you have a relation from most of the time a foreign key from the child to the parents. So you don't have actually at the level of the parents a list of all the childs. So that's difference between a relational model and an object model, where you can have easily within Java a list of all the childs within your parent objects, but there are then a few remarks that need to be mentioned about this bidirectional support and how you can handle that and what you need to take into consideration. Sometimes the way it's mentioned here, how the graph can influence the graph and the UI, but also how your user interface can influence how you should store your data. That there is that can sometimes be an important factor. And how can each entity be accessed, and then some cases about how you access those historical data as the purchases that we saw in the example. We all know the relational model, tables, primary keys and foreign keys, so you can have relations between the data there with the fields. Everyone knows that. But everyone also knows that your object graph looks completely different in the sense that you have an object 2, for instance, object number 2 here, which can have links to other objects, which then eventually can have object 2, a link to object 2 again, or object 5, which is linked twice which is presented twice in this graph. That's what's called the circular object graphs. Several people say that, well, those circular object graphs are not really a good idea because it gives you all kinds of troubles. But yeah, that is the case, that you need to watch out in some situations, that you need to be aware that it can happen, because otherwise you can, for instance, if your program is not aware of that, you can enter infinitive loops and those kind of things if you are searching through graphs. But on the other hand, it is common. There are common structures, that are common things that happens. Best example is the parent-child relations. If you want to model them, sometimes the easiest and the simplest way is to just use that list in the parent and kind of pointer to your parent from the child again. So, and then you have already a very simple circular reference. But the way that we store or that we access the data in the relational database, and an object model is also completely different. In the relational database, we have tables which represent the features of a certain aspect of your data. Like, for instance, you can have a car, but that here is not really a good example because the car consists of doors and wheels, etc. But you have some general things about a car, like the name, the brand of a car, etc. And then you have a list of doors, different types of doors, etc. And there is no direct link other than a foreign key from the door to the car, what it is. So you can find in the table doors, every type of door, regardless of which kind of car it is. So within the relational model, you always a table is always a collection, a store. You throw all the different parts at one pile together, and you have to find out which belongs to what through those foreign keys or whatever other means that you have to find out that a certain tire needs to fit on this certain car, for example. So that's completely different with the object model, where you have one car, for instance, and when one car consists of a set of tires, a set of seats, a set of doors, and each door, for instance, consists of a window and other things. So as I said, this is not surprising. We all know that, but that means that searching through data is completely different and can also be sometimes more difficult in a object graph. For instance, if you want to know all the different kind of windows types, for instance, what are available in your system, well, if you just have that object graph, then you have no other means than traversing each car that you know and selecting from each car the list of doors, and for each door the window, and then collecting all the data. So the database has already that information for you nicely put into a list in that collection, in the table, but in the object graph, you probably don't have that by default available to immediately accessible. So sometimes we need then also to do what's called a denormalization in the database world. In the database world, you store some redundant data that which is available within the database somewhere else, but is not that easy to access immediately. For instance, one of the classic examples is that you have the orders and the order lines, that you have the total amount of the order already in the order. But if you just take all the order lines belonging to that order and you sum up each amount, you also have that information. The same thing you can do, or you should probably do for some cases here in an object graph. Not with cars and windows, but for instance, with those shops and books, that's one of the things that we will look more in detail. For instance, if you have a shop and you have the inventory of the shop and then you have the books, then probably you want to have at a higher level all the unique books that can be sold within your company. Although that information is available already with the inventory, you probably want to have that already in a list also immediately accessible for whatever reason, so that you can have that list without the need to search through each inventory of each shop. So that's a few conclusions here from relational and object model. Most of the time, your relational model, in the sense, is the data is incomplete. For instance, if you have one record in a table, let's say in the table shops, you have one record, then that data is incomplete. What we mean by that is that you need to look into the other tables and see where the foreign key points to that record to have all the information, like the shop, what is the inventory, etc. So it is not possible to go to have all the information of one shop by just looking at one record in the shop table. There is some information about the relations, so within our, and not only within code as mentioned here, but in the understanding is that we need those relations, so we need those foreign keys, but actually in a database they are in the other tables, and so they are not necessary and they are not there in that shop record. That's what is meant there. Yeah, some people find that constraints defined in the database are not helpful for the developer also, but yeah, that's more a personal opinion of some people. A object graph looks more like the real world. As I said, if you have a car, then you see, oh, what are the components of that car? So that's a more natural way of looking things for us, looking for things in the real world. And from one car, you can go to all the details. So you have all the relations there. Probably you want to have all the relations there so that you can navigate from the car to the door to the window, and that you don't need to go the other way around from window looking up to the doors to the car, which also means that it is easier to access, because if you know already the car, then you can quickly access all the windows from that car. In a database situation, you need to more or less link those three tables and then define constraints. So it potentially needs more processing and more searching through the data, depending then, of course, about indexing what you have. So some considerations then. And that's also how you can store information in different ways in your object model. So that's and then of course you have to look at how you're going to use those data in your application, or how do you need to be able to access those data. So with a database, you don't have much choice. You need to use the tables and the fields, and you need to model your data in that way, and you need to make sure that you find all the data that you need. Here, as you will see with Java, you have, of course, and the object model, you have more choices, which makes it actually more difficult, because you need to choose the correct one for your problem. So you need to think about it, which is less the case with the database. There you don't have an option, so you can only use one way of storing data. For instance, you have a car, and each car has a brand, but each brand has multiple cars. So you have an end-to-one relation between car and brand. So you have different ways of storing that within objects. So you can have, for instance, within the brand table, a list of all the cars of that brand, and the car has no relation back to the brand. That's a possibility. Or you can, of course, have the other way around. You can have a car which has a brand, and the brand has no list of cars. Which one is best? Well, that depends on your use case, how you want to access the data. Because sometimes you also need both of them, and then you have those circular references between car and brand in this case, because within the brand object you have a list of cars, but the cars has also a reference to the brand. Again, it all depends on how you need to access your data. In whatever way you choose, MicroStream can store that. So even with that, as mentioned, with that circular references, that's no problem at all, because we store within the binary format at pointers. So that's not a problem. So we don't enter infinitive loop, which you have, for instance, if you would store it in JSON. There you only have values, which means that you cannot store recursive things. So you always need to ask then, if you design your data model, how are you going to use it? And also, for instance, does it make sense to have a car without a brand? Do I ever need, from a certain car object, do I need to know the brand? From the UI, and there comes the UI aspect in the whole story. Do we need that from the point of view of the UI? If not, then maybe we don't need it. If yes, yeah, then probably it is easier to have it within the brand reference within the car object. Let me think about, is it possible to have a car without a brand? Yes, so also, yeah, if it is it possible that you have a car without a brand name, then you can also use this one, because it's not necessary that each car object is represented in that list object within the brand. So so you see, it all depends on how you want to know it and want to use it. But around that denormalization aspect, you can have also, for instance, within your root object, a list of all cars and a list of all brands, and each brand has a list of all the cars of that brand. That's what I mentioned. Without a denormalization, you don't need that list of cars in your root object. You can find that through that brand, through those brand objects. But sometimes, most of the times, it is easier to have that kind of denormalization. This is another way of putting that same information that you have then brand multiple times in your object graph. As I mentioned, the UI can have an impact. For instance, if you want to have a list of all the possible categories here, then probably it is good to have that as a denormalization available, so that you don't need to search the entire database for all the possible categories that are used. Yeah, this is about those categories. If you have them only in your product, then or if your product does not have a category, then you might go the other way around, etc. So that that can impact your performance, because depending, even if it's in memory, searching through 500,000 items is slower than having the data already available. Of course, that bidirectional thing is a redundant information, which means that you need to write some code to keep it consistent. So if here the situation of a car with a brand and a list of cars in a brand, every time that you create a new car, you need to make sure that that car is also added to the list of cars in the brand. Probably you are familiar with all those things, that you have those add item methods, for instance, in a certain object where you add it to the list, but also make sure that you keep that all the data consistent, to put the other way around, the links in the other way around. But be aware that you need to do it and that you need to have some code to make it consistent, and of course a little bit more memory, because yeah, that list has then, you need to keep that list, and that's although not that much in this case, it takes a bit of more memory. Again, that's the norm of why you should have denormalizations. For instance, in an object graph, as I showed earlier in one of the slides, what if you want to get a list of all the objects of type 11 there at the bottom, and you only have a reference to that object 2, your root, that can be writing it is not the problem. Executing it, if you have for instance millions of items of that object 6, can then of course be some problem. Coming to that, also make sure with those large lists that you always have indexing. How do you do indexing within Java, outside of the database? The database, of course, you have an index on a certain field, and you can say where that index field is value. You can also search, of course, on fields that are not indexes, but yeah, at least most of the time you want to restrict your searches, or at least have some of your restrictions on tables based on indexed fields, especially if they are large. I'm only talking about large tables here, of course. If you only have 100 records in your table, then that's not a requirement, of course. And you can have multiple indexes, of course, multiple fields, an index on multiple fields, and several indexes on each field separately. So you all know that. In pure Java, you have something similar with a map. For instance, you can have that last one there at the map, where you have the author as the key value and the list of books as the second parameter. So instead of having one large list of maybe thousands or 100,000 of books, which is never a good idea if you want to search the books for a certain author, because then you need to look over all of them, you probably should create a map like this one, so that you can access the data immediately, what you need, having the list of books for that author. That's, of course, also a kind of denormalization. You need to keep it up to date. It takes a bit of memory, but at the end it will pay off, of course. And you can also have those indexes on multiple fields if you create a new kind of key value where you add two fields, let's call it two fields, two properties, as long as they have the proper requirements to be used as a key. So probably you need to be it is serializable, but you also need to implement equals and hash code, etc. of those key of those objects that are used as key values in maps. Then you can use that. I see there is a question. There are several questions already. Is there a way to make those bidirectional changes atomic? In the sense that, yeah, they are always two separate statements. So you can, of course, make sure that, for instance, with locking, and that's what I mentioned earlier, that you have those topics covered in the advanced section, that you have some concurrency mechanisms to make sure that when data is changed, that you're not reading the data, so that you're reading the data in a consistent way. But in the sense that atomic of one single operation for the JVM, that's of course not possible. So I think you mean atomic for the rest of your program. And then you need to use concurrency like locks or read, write, and entry locks, etc. Same for changes in the data model and supporting index maps. Is there a notion of transactions so that the changes become visible to other threads once they are consistent atomically? Again, within MicroStream, we don't have anything specific for transactions. So you can use all those Java functionalities around concurrency to make sure that, for instance, other threads cannot read the same data while you're updating them, for instance, for that index. So that's something that you need to provide, which you probably should do anyway, because you have here a single resource, your database. That's so that means that you need to protect it like a single resource in a multi-threaded environment. So with multiple threads, so you need some concurrency measurements there. There is another question: are there any kind of lifecycle events like after loads or something like that? So we can keep some of those indexes recreated in memory without having to persist them. That's indeed a good question. First of all, persisting them, is also just persisting the pointers. So okay, it takes some time to process and time to store it and space in those binary files, but it's not that huge. But secondly, well, the afterload is that when your storage manager is started. So if you want to process your data after it is loaded by the storage manager, then that's the way to go. But be aware that if you have lazy loaded data, which probably you have in most cases, that means that you are loading then the data at that moment into memory, also maybe only for a brief moment of time, but you are loading the data at that time, which then of course takes time, takes memory. Lazy loaded data can be ejected automatically when needed, but to come to that tomorrow. But probably from a performance point of view, it is easier to just have your those indexes also stored within the binary data. Yeah, so for historical data, a large data set also in general, which most of the time is the same, because historical data is mostly a large set of data. You should not, as mentioned, you should not keep them in one giant list, but apply some kind of indexing by year-month combination, whatever your need to access it later on, then that depends how you need to access the data, of course, later on. And that will allow you to have a lot of data which is not loaded by default, but only lazy loaded when you actually need it, for instance, for some reporting or some exceptional querying of past data. Okay, there is an example, but not going to that much in detail, but you can play around with it. But I guess you all know those things, as I mentioned, more or less, just that you are aware that you should do those things. So we have a company, we have books, we have authors, we have stores, customers, and addresses, and we have a sale. So we have purchases and employees, more or less what we have seen in that performance demo. So you could create a object hierarchy like this. You have the company, which has an address and list of stores, and each store has then a list of books which are available in the inventory, which can be bought in that store, etc. But you see, this is a really nicely structured object graph. If you may call it so, you just have top-down things. But as I mentioned, probably you need to have access to the books. So you probably need a list of books also at the company level, a list of employees at the company level, etc. So that's some kind of denormalization that you need to do. Yeah, also, as I said, what if you want to find by author or find where books of a certain author can be bought in which store, then having only this is, of course, not the most optimal structure. There is, for that example, I created here the object model example. So you have already all the objects there. You have the company, employees, sales, stores, etc. And you have created I've created as, for instance, the list of stores, but also already a list of customers, although a store has probably here on each sale for a certain customer. You can play around, but yeah, most of you are seasoned developers, so you all know what to do. So I'm not going into detail. I'm not going to spend here much time on it. I think there are more interesting things to learn about the configuration. Are there any questions for the moment? There were already a few about the data model, or any other questions. Otherwise, I think we can go for our lunch break. Yeah, is there a good reason to use here that UID to string instead of standard UIDs? Well, actually, no. Now that you mention it, it's probably because I'm still having the idea that I'm working with a database, and that's what we see with many developers that are working with MicroStream. They are so used of working with a database that they keep thinking in database terms. So UUID, you cannot store it by default. You can store a string. So that's my fault. I'm used of writing these kind of things because I need to store this ID into the database. Actually, now that we have MicroStream, you should not use that, and that's indeed a good point that you should use it something like this. Sometimes it can be more efficient to use such primitives as strings, but I'm not sure here by UUID, because storing this in a binary format might be less efficient than a string. But in general, I would say, no, you're right. I should have used this one. So, yeah, I call it lunch break because for the US time zone, it is now more or less lunchtime. So in an hour, we come back. So I keep this Zoom session open, so you can also keep on connected. You're free also to disconnect. I can join you in later on again, that's not a problem. But I keep it open and running so that you can do it also on your side. So I see you then back in 1 hour for the next thing. One of the important things is about which is configuration. So welcome back, everyone. At least most of you have already returned. So there was the question if there was a recording for today. So as already answered by someone, yes, it will be sent later on, not today, but you will get the recording, the link to the recording. And the examples on GitHub, yeah, they are created for JDK 11. So if you want to run on JDK 17, then you need to use a specific Maven War plugin, which is capable of running on JDK 17. So then you need to define the plugin and specify the version 3.3.2 to have to have the War created with JDK 17. But with JDK 11, you should not have any problem. Any question that came up when you had your little time off thinking about what you have seen in the first few hours, or should we continue with the most important task of MicroStream, which is configuration? So I don't see any question appearing in chat, and no one is unmuting himself. So I'm continuing then with the configuration part. The most important, the most difficult, but actually it can be done in a single statement, but it's the larger task because you have all the different possibilities. Yeah, you have at least 4 different possibilities to define the configuration for that storage manager. The storage manager who is responsible, which is the, let's say, the root object of the entire MicroStream object structure, which maintains your data. And the configuration, either if it's minimal or the more elaborated ones, as you will see, they all have one thing in common. What is needed for the configuration is that you make the link between your object graph and where data is stored, so that when the storage manager starts, data can be read from that location, or when you change, when you say store me some data to that storage again, which is by the end of this day, where the serialized binary data needs to go then. That's the main task of the configuration. Of course, with the configuration, since MicroStream internally is completely built on top of interfaces, where you have always a default implementation available, but everything is practically an interface, which means that you can change every little piece of the system itself. There are like 25 main subsystems. We are not going to cover them all. Few of them, we cover them, but actually all of them can be modified to your needs. Which makes it, of course, very powerful, but if you want to do the configuration, the configuration into every little detail, then of course that is a huge task then. But as I said, default implementations are available everywhere and picked up by default. So that's something that you do not need to worry about unless you want to change a specific functionality, a specific piece of MicroStream. So I'm going to show the entire configuration options and possibilities through demos, through code. That is, I guess, the best thing that I can do. It's available in that config directory on GitHub if you want to have a look at it later on. And first of all, there is for the storage manager itself and all those dependencies, as I mentioned, you actually only need one artifact, one Maven artifact to have all those interfaces and default implementations. That's here the storage embedded one. So this second one, that configuration, is, for example, not needed for the simple one, which I'm going to start with, because it is just configuring the storage manager directly with the two required parameters, the root object and the location. But in most cases, then you need that second artifact here, that configuration artifact. So most of the time, you always see a project where you have these two dependencies. And if we look at the dependency, which are then imported in your IDE, for example, or imported in your project, you see that there are only the MicroStream dependencies. One exception, that SLF4J API, which also is coming in. More on that in a moment. But as you see, we explicitly have chosen for a solution, an implementation where there are no external dependencies. There is no dependencies on, let's say, Guave, Apache Commons, or any other kind of library. Because, okay, you can solve it, but it is also possible that it brings you some dependency mismatch, dependency conflicts, if you are using those in your project. So we have some utility classes, we have some helper methods, etc., but all of them are included in one of those MicroStream artifacts here itself. For instance, in the base, if I can find them quickly, you see you have here, for instance, a util with several classes, a lot of interfaces, and here this X one is a bit of the solution that you have in a object-oriented programming when you just need some kind of static method, static helper method. So that's they are grouped here in this X class. One exception, as I mentioned, is SLF4J. That is a new dependency since version 7. Because from that version onwards, we have the capability of logging what it is doing internally when it starts up. When it stores data, you have the classic info, a few info statements, or you have the entire debug level where you can have a lot of information of what it is doing internally. for debugging purposes mainly, or if we need to find out something, or we need to research something. But SLF4J API, that's known that it is really backwards compatible. So any kind of 1.7 version of the API and even of the actual outputting of the log, for instance, here, just using the JDK logging facilities. So there should not be any conflicts around that. So that's not really a problem. So once we have the dependencies, we can start making the configuration. And as mentioned, it can be a single line, but most of the time you will need something more. But you can start the storage manager with a certain with the two parameters required for the configuration, which is your root object and a path where the data is stored. Quick recap, we can store MicroStream serialization engine can store any kind of object, can serialize any kind of object, so not only the implement serializable one. That was a reason why we created something new. One of the reasons, the data model evolution that we discuss tomorrow is also another reason. But we can serialize anything by inspecting the structure. For instance, it has here this is excluded, as you can imagine, but you have here a list of users, etc. So these are then stored or loaded when needed. So no requirement on an interface, an annotation, superclass, a schema. Has a lot of serialization frameworks requires a schema and then generated code that can handle data within that schema. So it is a purely general purpose, which then means that, because coming back to that question, which was there earlier, how do we compare to CRIO, for instance, or FST? Through that fact that we are so general, we are somewhere in the middle. We are not the fastest, we are not the slowest, so we are somewhere in the middle, both in terms of size, the amount of data which is generated for a certain object graph, as regarding the speed. So we are somewhere in the middle. So this single line is then enough because it fulfills the requirement that we at minimum need to say that this root will be stored into this location. So I've created here a helper method to see if our root contains any data or not. So from the storage manager, you can retrieve always that root object which is configured there. So you can always have access to your actual data if you have access to the storage manager. In case there is no data, so for example, you see I'm referring here to the path simple config. That's not here available in my project, so it is empty. So that means I have an empty database, more or less. That means that that root object will be empty in the sense of Java. So that means that, sorry, I was a bit too fast. We create here a new instance. So if our database is empty, so if it does not find any binary data on this location, it keeps this initial object that we have created. So that means that we have an empty list for users and an empty list for books. That is at some point important because I said there is sometimes magic going on behind the scenes. So that's important to know that when the database is empty, we keep the initial root object, what is provided by the developer. So we can check then if there, here in this case, if there are no users yet, then we have to add some default data, and the John Doe and Jane Doe, for example, and 13 books. And some books are assigned to those persons. So think this as a simple kind of library thing that some books are lent to those people. If we see that there are already users, so that means that, okay, we assume that we have some data, probably more than these two fake data, but yeah, if there are already data, then we have something available and we don't initialize it. That's not a good one, this one, the test application. So this is what this line is doing. We print out then the list of books and yeah, just also the size here, because that makes more sense than, of course, looking through each book. We have to see if there is no doubles if we run this twice. So running this means empty database, our root is empty, empty list, it adds the data. And we have those 13 books here. What is also here at the end, but that's something is it not here? Okay, I was thinking that there was somewhere a store, because if we run it the second time. But now you see that that simple configuration is created, and there are two items, let's call them, in the directory. If this is within a database, because we have said that we can also put this binary data in, for instance, a database or S3 or whatever kind of storage, as long as it can handle binary, some blob data. There are two things. One is what we call the type dictionary. So within the binary data here, we don't write any class info. So if we go down at the bottom, we see our book. Our book received a unique number. Actually, this class received a unique number for this kind of data, because when you are modifying data, you can have the same class, but another unique number if you have, for instance, another field here. But more on that tomorrow on the type legacy mapping. So instead of putting some class names into the binary format, we only store unique numbers. And then for the string, we store, of course, that it is a string, because string is also as a list or as a array of characters that has also a unique number, and we store the value then for that. So that's one of the reasons why our serialization is secure, because in that binary data, there are no classes, the class names mentioned. So you cannot add a random class as and see if the system tries to deserialize it, and then you have those side effects which you have with the standard Java serialization and deserialization. So the binary data are here in what's called a channel. I come more in detail to what the channel is in a moment, so that we can first concentrate a bit more on this configuration. But I wanted already to mention how data is stored. So I'm wondering now if I'm doing the correct thing, because okay, if I run, okay, then I have to look up because I did not see it immediately where did I store the data. But if we run it the second time, then this start sees that there are data and it fills this root object. So actually these two lists with the data. So we don't have anything to do, but you see that we still have the data, of course, which were available, which were added the first time. So this is the minimal line, the minimal configuration that you need to do, but most of the time with some kind of proof of concept, etc., that might be enough, but most of the time this is a bit too simplistic. But are there any questions already about the principle? Because these two items that you need to configure for a storage manager, of course, are the main part. So that's why I wanted to show it separately. So any questions about the configuration that we have seen already for the moment? Apparently not. So let's continue then to the case where what is more or less more standard way, a more real world way of creating your storage manager. And that's through a kind of builder. This builder is only available in this configuration artifact. So that's why I said that most of the time you have that in your project. And yeah, as a classic builder, you have the options to set each different aspect of the configuration through a method. You still have here that set storage directory. So this means that this directory is used to store the data and the persistence, that type, that dictionary, and those channels. You can set, for example, here now that we have 4 channels instead of 1. In the previous, you could not define it in the previous simple one. Now you can define 4. I come in a moment what those channels are and where it can be imported. You have a few other methods here. Well, a lot of other methods. Actually, you have what we call a backup directory. Backups are discussed tomorrow. You can define some parameters on those data files. These are the data files, and by naming, should it be channel underscore, or should that be something different? Should that be a dot file, or should it be something else? The prefix and the suffix, the minimum maximum sizes, etc. So you can, as you could imagine, can define a lot of configuration parameters for the storage manager through this builder. Not all those configuration, as I mentioned, for example, everything is an interface. So how can you change those types of implementation for a certain interface? That can be done in the second step. So the first step is that you have things which are more or less simple configurations like location and count and file names, etc., etc. And then the next step is that what we call, you create a storage foundation out of that. And the storage foundation is taking into account your configuration properties here, of course, but then also already creating for each interface the default, or using for each interface the default implementation. But from that point onwards, once you have that foundation, you can change those implementations. For instance, you can register additional type handlers. Type handlers are the pieces of code which are responsible for converting from a Java object to the binary representation and vice versa. So you can register additional ones, more specialized ones, or those kind of things. You have here what's called the root resolver providers and suppliers. You have the type evaluator persistable. That's something that comes tomorrow. So you can do here already some things directly on the foundation, or you can use here, for instance, that on connection foundation method, where you can set other types of default systems or change them, like the storage systems, what we call the persistence manager internally, etc., etc. These are quite advanced things. So once you are dealing with methods on the foundation itself, except then maybe this set root, because that defines the root on it, then you go into the expert territory, and that's not a problem if you know what you're doing, but you can also break the entire thing down, of course, if you are not doing it correctly. Can I put the set directory method is a question elsewhere on my PC? How about always headache? Yes, of course. This is now just a local, it's not a global path. It's a relative path. Depending on the system where you are, of course, I'm running on a Mac machine, so that means that I have something like users, my user, etc. You can use any kind of directory which is available for your system. That should not be a problem. How about slashes, etc.? Always a headache. You mean something like if you do like this, if you start with a local, or you start with on the home path, etc. Is that what you mean with slashes and headaches? But basically, this kind of things is related to the operating system, and as long as you follow the operating system and aliases, etc., and forward backslashes, etc. Yeah, it might be. Yeah, it might indeed sometimes tricky to find out. But if you remember what the rules are about relative paths, like this is a relative path or this one is an absolute path, then you should be able to figure it out normally here for MicroStream. So as I said, first we have the simple values, the simple values that we configure, like directory and channel count. Then you have the foundation where you can do the advanced stuff. Don't forget to set the root. We create a storage manager out of it, out of the entire configuration that we have, and we can start it, and we can again set default data and see what happens when we list the number of books at the first time. Again, there is no data because I've used here another directory. I needed to use another directory because I changed the channel counts. I'm going to explain what it is. See, adding the default data when I'm running it the second time, it should be there because here are my data. So I have those 13 books and those 2 users, so it's not going to create it again. So what are the channels? You see now that there are 4 channels, so you have 4 times the data. Is that a duplication of the data? No. What is a channel? First, a channel is the, let's call it that way, it's the thread, and so the process which is responsible for the serialization and the deserialization, and writing it to the, in this case, file system. So those two tasks are performed by the channel. If you have one channel, then if we store those 13 books, then yeah, the storage manager, actually that persistence manager that you saw there passing by in one of those methods, is responsible for passing then all those books, all those that list and all that information through the single channel which there is, and that one is then responsible for creating the binary version and writing it to disk. So that means that we have one process which writes it to the disk. If we have a lot of data, then it might be faster that we use multiple threads instead of just, because on most machines you have more than one core available. So by scaling it up to 4 for your instance, you can probably have an increase in throughput, because then an object is then passed to one of those 4, and the reason why it needs to be always a multiple value of 2 is that because we are using the last X number of bits of the unique, how is it called, unique pointer, which is assigned within Java for each object. So that's why we need to have a multiple value of 2 so that we can do a XOR function, or is it an AND function? How is it called? So that we can determine where each object needs to go to which channel. But that means that the converting to binary format and writing to disk in this case can be done in parallel. And so 4 processes can do the job of only one here in that previous one. It will not be 4 times faster because you have a little bit of management and overhead, but you can imagine there will be, especially with larger systems, with larger data sets, there is an advantage. How many channels should you have? Well, at least no more than the number of cores on your machine. For instance, if this was a very low key system on the cloud with only, for instance, 1 core assigned to it, then this would not be helpful, assigning 4 cores. On my machine, I have more than enough cores, so 4 will be here much faster than 1. Well, much, it will be faster. Much is, of course, relatively speaking. Okay, so to answer your question on another location, so that was then where you can store it. So the person used a absolute directory on Windows using the temp ctemp builder config, and that saves it in the temp directory, yes, with no issue. So just make sure that you define here what you like, and then here in this case you have 4 channels then doing the job for you. So this is most of the time, well, no, it's one of the because there is also another one. This is one of the important ways how to configure the entire storage manager. Any additional question around the usage of that builder and then defining all those interfaces here with, for instance, that callback method? So obviously, here we have hard-coded the values, which is not good. You know that also. So you can read these individual values from somewhere, environment variables, a config, using a config mechanism or whatever. You can use them individual, those individual properties, you can name them yourself and you can read them and you can use them. So that's perfectly fine, that is possible. But we have also defined our own reading of external configuration. By default, we support property files and XML files. So here, instead of just compare it with the builder one, so if you compare the number of statements or which kind of statements I used here, so if you compare it to this one, so all what you have put here before that create foundation, that create storage foundation, you can replace that by just say, load me those values from a certain configuration file. And that configuration file I have defined here as a.properties. So I have here on my class path, but again, you can use any kind of location as long as you put the correct absolute paths. Then, for example, there you can use these kind of key value pairs to define the configuration. What keys are available? Basically, they are the method names, the set storage directory, set channel count. If you like to have a list, then this is the list. It's in the documentation, in our reference manual. Where you have that storage directory, for instance, the channel count, and also that file prefixes and suffixes, etc. So you have them described here with some explanation of what is going on. So instead of providing your own way, which is perfectly fine, but suppose that you just say, I have somewhere or I will provide somehow a file with the configuration, then I can use that with load storage foundation. I can do the same things as before, and that on connection foundation, I can set the root, create storage manager, and I can start it. And I can run again the application. This time it is on, it's this external config called. So you see, he creates now with 2 channels, create something else. He has created the data again. If I run the second time, he sees that the data is already there and it's nothing to do. Coming back to that question, what if I reduce the channel count or increase it? Will it still work or not? Well, no, it will not work anymore. Because, for instance, I can change here for XML. That is possible, because the only thing what is different between those properties, and I've closed it. And I have here my error. The only thing what is different between the property files and the XML file is that, yeah, just the formats, how they are defined. Because the values, external config and 2 channels are identical. Storage directory and channel count is 2. So the only thing what is different is that it is placed in an XML format instead of a key value pair. So that works fine. But what if I change here 1? Then we find out that your initial, your database was initially created with another amount, another value for that channel count than what you are running now, and you will get an error. Found, see, he says that somehow I found 2 channels, and now there is only 1. I am suspect that it is just based on these names. So what if I drop them? Then I can run them again. I don't have probably the error. This is, yeah, you see. Coincidentally, I have the same number of books, which is not the ID. You see. Apparently, my definition, this is already a bit of an advanced thing, but it's fine. There was that question. I'm happy to explain those things, but it can be confusing maybe if you are just trying out MicroStream for a few hours like we do now. Where is my root? There's my root. Our root object is a list of users and a list of books. Apparently, the root itself was in that first, in channel 0, but the definition of our books list was in the second one. So when I deleted the channel _1, he loads the data for roots and he scans channel 0 and he finds data for root, which is fine because otherwise you have also an error when it doesn't find the root. But then apparently he did not find the definition for list of books, so that was still empty, still the default what we have here defined in our Java code. So that means that our ensure initial data method sees, oh, there are no data, let's add those 13 books. So yes, don't start messing with the number of channels. So does it mean that you can never change it? Well, no, it is possible. We have a conversion utility which can convert the storage from one location to another location. So you can copy it from one directory to another directory. You can convert it from a directory to a database. You can convert it from a database to a directory, whatever you like. You can convert it from old to new. But there you have, of course, the possibility to define the new configuration with a different amount of channels. Then it reads the data properly with the number of channels from the old configuration and writes it with the configuration of the new set, which is defined in the new configuration. So you can change it, but yeah, be aware that you should take at the beginning some kind of consideration how many channels you should define. Then probably some of you have the question, well, what should I use? And 1, 2, 4, 8, whatever. Well, I would say 1 or 2 is the most common one. Unless your application mainly writes a lot of data in one block. So suppose that you have some kind of processing going on within your application where you upload a large block of data, let's say, I don't know, a few thousand records or whatever, then you will benefit from more than 2 channels. If you are just having the normal transactional, and transactional means the amount of data which is associated with UI, so that the user enters a few fields, a few create a record or delete a record, then yeah, 1 channel is enough. is there a sample to configure the storage to some remote location? If you mean database, etc. And yes, that's something that I can cover tomorrow. But basically, you will see that it is more or less identical, but I can cover it for tomorrow. So that's something that I'm going to mention and that I'm going to note down so that I don't forget it. So example of, I can show you the S3 one and the database one, and then you have most common situations. Have you ever tried with millions of records, let's say 50 or 100 millions of records in batch processing? I have create a performance test with 4 million of records, which I wrote at a certain moment, in one block. And with 8 channels, that took me around 30 seconds on my machine. If you compare that to a database, because that was the goal, then it was around 9 to 10 times faster. So storing it in a database took around 3 minutes, 3-4 minutes, and those 4 millions I could write with 8 channels in about 30 seconds. I did play around at that moment with the channels, trying with 1 channel or 8 channels, and there was a difference, but I think it was with 1 channel, it was around 55 seconds, if I remember correctly, and with 8 channels, it was around 30 seconds. So as you see, it is faster, but not X times faster than the numbers of channels. So either you use, as I mentioned here, the individual values and you can retrieve them from whatever you like. Not going to cover it in detail, but we have those integrations. And for instance, for Spring Boot, then these values can be used not like this, but in a similar way, that the data is loaded from the Spring Boot configuration. And then, or you can use them, of course, like here, properties or XML. It's up to you what you find the most convenient way of configuring the storage manager. And the last one, the fourth way, is then using the programmatic way. Again, you can again load them from any kind of system. But yeah, actually the long way. So this gives you access to every little detail in a quite extensive way. For instance, that writing to disk is the default, but actually we have something what is called the abstract file system, AFS. So the channel writes to an interface. Again, it's configurable. By default, we define there that we have a implementation for the file system using the non-blocking I/O of Java to write out those files with that binary data. But in the long way, you have here what's called a storage file provider. It provides you the class that is capable or that will be used to write that storage file. And again, we provide it through a builder with a certain file system, which is then in this case the non-blocking I/O file system. that can be then also be the database. That can be S3. But again, there are somewhat more convenient ways than using this more elaborate way. But this is actually the way if you want to change, let's say, 30 to 40% of the MicroStream defaults, if you want to change them, then this might be the way to do it. Again, let's call this expert mode, because you see you have always providers also for the channel count. You don't just provide a number. It's through a kind of provider, etc. So it is rather expert level. Let's say that. Here is an example, what I mentioned earlier about JDK 17. There is a artifact specifically designed for JDK 17 with those new collections that there are a few new additional collections defined. They are not defined in 17. I think they are defined in 14 or 15, but yeah, we bundle them to the long-term supported Java versions. And then to register those so that MicroStream can handle those, you could register them through that on-connection foundation. Or if you have in environments with multiple levels of class loaders, because then you can have a different class loader that loads that root object and your application class loader, then you might need to set also the class loader that provides that root object, etc. So that are a few expert settings, but most of the time, for instance, if it is needed, for instance, within Spring Boot and Quarkus, this is needed, then it is done automatically for you. Then, of course, you don't need to worry about those things. There is another question. Can you put the channels on different directories paths? No. So we have here 4 channels. It is not possible to put them in a different directory, unless probably on Unix machines, if you create already the directory and create 4 aliases to other locations, then he will use those aliases and you can move the data to different locations. So you are probably thinking about reducing the I/O for the disk, because yeah, if you have, for instance, 4 channels, you have 4 processes writing those 2 channels, but yeah, it's still the disk that needs to handle all those I/O. So I guess I did not try it out, but I guess if you have something predefined as a structure that points with aliases to different locations, that you are able to manage to put the actual data files into different locations. But it still appears as to be one location here within that directory, but through that alias functionality, they are stored so somewhere else. Other questions? Because that is most of what I wanted to say for the moment about configuration. So configuration needs to do at minimum 2 things. And they are shown here. That is link the root object with a certain location. Optionally, you define them through a builder or through that external file that external mechanism, and optionally you define here some additional overrides that you override the default implementation of MicroStream with your own, or you add one like those JDK17 binary handlers, or change the class loader for that particular part or whatever. I'm going to see if I have something here on the slides. Yeah, I have here on. But if you have questions, please put them in the chat, or you can unmute yourself and ask it. And so, as I mentioned, that channel mechanism, that's a separate thread. The storage manager hands over a certain object to one channel if there is only one, or one of the multiple channels if there are more, depending on that pattern, on that bit pattern. Channel is responsible for serializing and writing it to a kind of abstract file system implementation, which can be disk using the non-blocking IO file system, can be SQL, or can be a general blob system, which we are using, for instance, for the cloud storages like S3. I have noted down that I give an example of that tomorrow, so that's something that we can cover then in that to be defined block, as you have seen this earlier this morning. Yeah, here a few more words on that channel count that need to be then a power of 2, so 1, 2, 4, 8, or 16. And based on that, on the system identity hash code, which is the default implementation of hash code if you don't override it for your object. So that returns a pointer. It's not an address memory because it stays the same for your object the entire time. Also, although the garbage collector can move your object, and that pointer still stays, that hash code, this identity hash code stays the same. And based on that binary notation, then of course we look at the number of bits. So if you are having 8 channels, we look at the 3 last bits and determine the channel number based on those 3 last bits. Other configuration aspect, as I mentioned, that's for instance, that on connection foundation callback method, for instance, for that class loader, and specialized handlers for that JDK17. We have also some JDK8 optimized ones. So that's also something that you could have a look into if you want to improve speed and performance. So I propose that for those who did not do it already, because based on the questions, I see that some people already played with it, which is of course fine. So I propose that you play a bit with those configuration options, or at least one of them, and then I would say that that builder one and the external configuration one are the most interesting one to play around with it, so that you play a bit with those examples, and so that you have a little bit of hands-on experience already, because we end this day with a exercise. So already good that you have some questions and that we can handle those questions now, and that we don't need to handle everything at the end of the day. There is a question, will virtual threads work with MicroStream? yes, that will work. That's not a problem. But for the moment, we are not using virtual threads. Of course, first of all, they are in a preview feature of JDK 19. So, yeah, it might be the case that in a future version that we implement and that we are using virtual threads within MicroStream. But from the application, okay, virtual threads is a big thing, and there is an important difference between normal threads, naming operating system threads, or these virtual threads. They are managed completely different, but from your Java code, there should be no difference. So I don't see any issue with using virtual threads in your program, or as I said, in the future, if we are using virtual threads, for instance, for those channels. Because then, of course, we could benefit from the non-blocking I/O, or better scheduling things around I/O and those virtual threads. Of course, we can make use of that. So someone had an issue with using a NAS-mounted network drive, but try to find it in the code, but I have no idea how that should be possible. Because at shutdown, he tries to shut down itself twice. Anyone has another question or remark or something related to this configuration? So we have now done the configuration. That's one of the two main parts of MicroStream. Yeah, reading your data, as we have mentioned already, that's just using Java. MicroStream does not play any role in that, so I'm not going to cover that today. Tomorrow I'm going over the Java 8 Streams API. Probably you know most of those things, but there are a few tricks maybe that are useful that you are aware of that you can use. So then the other thing that is left for today is then, of course, how can we write the data back to our storage system if we have made an update, if we have inserted records. I'm using those terminology, but of course it are objects. And for that, and also for the exercise later on today, yeah, it is easy if we have some kind of web application where we have some REST endpoints, because then you can send some data to it and you can store the data which you received from the client. You can also do your selection and then return the data. So yeah, simple Java SE program, which we have used up until now, is then not ideal anymore. So that's the reason why I have there now a small introduction to what I call templates that you can use for your exercise later on. I tried to see during the break earlier on if I could create a poll, but apparently I don't have that kind of superpowers to create polls here on Zoom. Because yeah, there are many frameworks and I have created for 4 of them an example, not really production quality in the sense that I'm not using the integrations that we have, for example, for Spring Boot or the CDI integration for Payara Micro. Again, trying to get those things as simple as possible. So I prepared 4 of them, and I'm not going to explain all of 4 of them because actually there are, in the sense how we are using them for this example and this exercise, identical. So I'm not sure what is the preference of people, how I should explain the templates. Can I use Payara Micro, which I'm most familiar with, or are there more Spring Boot fans? Or so now is the time to to make your statement what I should cover next. I see that there is a question. Quarkus, is that already supported? Not in this version, because the Quarkus version 2 requires JDK 11, and current version of MicroStream version 7 is still on JDK 1.8. So that means that the integration is not available yet, but it is there in the sense that there is a pull request open that will be available in 8.0 when we move to JDK 11. So if you check out this pull request, you actually could use it already as an integration. But again, this one, so you can actually use it for this example. Wait here. This one is not using the integration, so you could use it for today and tomorrow. I see there is someone who's saying, I'm using Spring, but he's flexible. So come on, people, what should I do? Can I just choose then Payara Micro? As I said, it's all identical. Huh? It's actually using a singleton pattern. Choose at random, Payara Micro is fine. So for those who knows me, yeah, I'm coming from, I did work for Payara quite some time, so I'm still using that. Yeah, so indeed, there is not much integration. It's just that we have something. So, and you can start by taking the template. They are all identical. The same classes are placed everywhere. There is maybe a little difference here and there, but if you know the framework, then it should not be a problem. So on top of your normal framework, you need those 2 dependencies, which we have already covered. So that's not a problem. And then I have created for every of those four templates, I have created mainly 2 classes, which is called, as an example, called something DB from database, which is responsible for creating your storage manager and keeping track of your storage manager. You see, I'm not using anything of CDI specific here. I'm just pure as a singleton pattern, a final class with a private constructor. And here a get instance. So when I don't have a storage manager yet, I initialize a new root object. In your example, you probably should change that root object, or the exercise of this afternoon is called company, the root object. If you want to use that, you can create that, you can change this object, whatever. It's not that important. And then you create this storage manager, and that should be familiar because that is that builder pattern that we have seen in the previous section. After the storage manager is started, we do again an init data, but that's just some hard-coded data to get something started. For instance, here, if the product is empty, I just add one product there. This is then, okay, something that I will cover in after the break, to cover how you can store data. So by the time that you can start on your exercise, start working on your exercise, that should be clear what I'm doing here. And that is basically it. So in my controller, in my endpoint, how do I access then my products? For instance, if I want to return all my products, then I just call that singleton. I call that get root, which gets it from the instance. If not, it creates it. He returns all the products and returns the response for it. This is, of course, a bit different for all the 4 templates. But these 2 classes, the database and root, and I've put that product here. And for some, I have this initialization of your REST endpoints. But these 2 classes are available and are the central part that you need to know. And the rest you should be familiar then if you're working with Payara, working with Spring, working with Quarkus, how you should implement these kind of things. So again, this is not really production quality. I don't think everyone is willing to do this in a real world application, but I try to keep it as simple as possible so that everyone can take their framework from their choice. There is a question, are there any plans to develop something like the typical MicroStream starter where you can configure the storage from properties? Well, actually, those integrations, they have that capability. So maybe I go over the real integrations tomorrow, maybe a bit, and then you can see that that we have that already, that configuration part from properties, that it is already available. So that's just a brief intro about what it should be, how you can use that. Again, kept this as simple as possible because I want to focus on MicroStream. So after the break, then I think I don't have anything specific here. With that singleton pattern indeed. So after the break, then we start with how you can interact with the data, especially storing, externally store it for safe process restart, which is then the second important part next to the configuration. So I propose a 15 minutes break, and then at 15 past the hour, we come back and see the last important bits and pieces for today. See you in a moment. So, welcome back, everyone. We are going now for the last block of today. And yeah, as you will see, we are coming to a more or less functional working application. We have seen now all the bits and pieces. Started with the data model. Then how you can do the configuration, reading, as you know, pure Java, so I'm not going to say much about that today. And then once you have made some changes into your object graph, we will see now how you can change those data. So, as I mentioned already, when the storage manager is created, that object graph is loaded from that storage location, except for that first time when it's empty, but okay, that's the exception, I think. You have some data, it is there in memory, and from that moment on, that memory is your database. That's the idea of MicroStream, that object graph in the JVM is your database, your primary source, so where you are doing all the work, reading, updating, etc. So there is currently no simple API available to do a reload. For example, that you say, I have made some changes, but for whatever reason, I need to do some kind of rollback, then reloading a subgraph is possible. That's part of the advanced course, but it's not a single method on the storage manager, for example. So for the simple reason from the ID, the philosophy of MicroStream, that once your data is in the JVM memory, then it's up to the developer and Java to handle those kind of things. But it is possible either through lazy loading, as I will briefly mention tomorrow and cover lazy loading tomorrow, or as you will see if you follow the advanced training, how you can reload a part, mostly a part of your subgraph. You can read everything again back, of course, also, but that's most of the time not wanted. What I'm going to mention now are the rules about storing the data. So you have your object graph. You have made some changes. Some objects are changed, some other not. And then how can you make sure that the data is again stored in the binary format in that external storage system? There is only one important method, which is the second one: store a certain object. The store root is then the special case where that object is a root, and you can use that store root method, but normally you never use the store root method. You always use that second one: store a certain object. There is a graph on the screen with some color encoding, meaning that the brownish or orange-like things are the changed ones, and the green ones are objects that are not changed. So, for instance, the string can be the same, So that means not changed, or the object reference. So for instance, if you have a list of books, then there is no additional book added to the list or no book removed from the list. That is what I mean by an object is changed or not. A bit more nuance in a moment. So if you say store me an object, for instance, store me object 5 there, the green one. By default, if you just say store object 5, then it's what the lazy storer is used. What does that mean? There are two types of store objects. And the default one is the lazy store lazy storer object, which traverses your entire tree or your entire graph, but stops when there is any unchanged pointer. So if we say that it needs to store object 5, then actually it will do nothing at all. So it will not store the changed object number 4, which is at the bottom of that subgraph. Because it starts at 5, it sees that 5 itself is not changed, and the pointer to 9 is not changed because that was there already before. And that means it stops there. It does not go until the end of your tree. So that's a really important thing. You always need to think very carefully about what is the root, the subroot that you want to store, and will it store me everything? Because if you say, for example, store me the root there, store me object 2, if that is a root or not, that's okay, that's another question, but store me object 2. With that lazy storer, it will store the changes in object 7, 6, and 11, but not 4. For the same reason, the link between 2 and 5 is not changed, so that means that the lazy storer stops there and does not go further. As mentioned during the introduction, we store only the changes. We don't make an entire snapshot and we don't store everything, because if you have a lot of data, then you would store a lot of data for no reason because it is not changed. So we are working more or less like the GitHub system. Like Git, where we store changes and then afterwards we assemble the root again based on all the bits and pieces and reconstruct the tree as it was before. So important, by default, the lazy storer, if you store object 2, it will not store that object 4 there. But there is a other storer, the eager storer, and that was the one that you saw me using already in that when I mentioned there the templates. And the eager storer stores all objects, no matter what. That is nice, that's easy, but be careful when you use it, of course, because it means it stores everything. But for example, for an initial population of data in your root, when your database was empty, or for some special cases where you want to force a certain value for that subgraph or something, that is of course very handy that you have the eager storer and that you can store everything. That was also mentioned there in the beginning. That's the reason why we have, besides the actual object graph that your Java object is using, we have also what's called a object registry, where we keep all those pointers. So we keep not the actual data from a string, for example, but we say, oh, for instance, that object 4 was a string, so we keep a reference to that string, that it was there in object 9. And so when the storer sees that the pointer is different now, then of course, then we know that it is changed because their string is immutable. So that means that any change of the pointer means that the string itself was changed. We come to that with some examples because that's one of the important things to determine what exactly you need to change and what you need to store after what is changed. So the rule is, as the title says on the slide, store what is changed. So always determine what is changed. Is it an object? Is it a POJ object itself? Is it the list? Is it whatever? Some examples in a moment. And then that is the subroute that you need to store. Altered, modified, transform, different, whatever, as long as there is some kind of change that you want to be persistent externally. So I have here based on the template, a application which is incomplete in the sense that most of the time I need to enter here something. I have, in case I've lost my way, I have already also a solution, and then that means also that you have a solution. If you look at the GitHub repo, and the idea is that you have again books and an author. And I found some real data where you have a list of quite some books in JSON, and also the corresponding some authors, and the authors are correctly linked to the books. And I have a method which actually reads the entire JSON. So, and I call this load mockup data, then I get a list of books with the authors nicely assigned to it. And I have here a set of endpoints. Probably in the real world, you should have created multiple classes, but again, for simplicity, which does a few things, and reading is there, but writing is empty, so that you can so that you can try playing around later to see if you have mastered the storing of the data with MicroStream. So let me start up then the program, and then we can see live if we have done it correctly or not. I could use the IDE because there are plugins and etc. And I could use something more than sophisticated like auto reload, etc. But I'm going to do it really easy. So I'm going to just run it time after time. So it is, how is it called? CRUD. Maybe I should not have run it already for the first time, because there is not that much in, because it's an empty database, of course. So I have those JSON loaded, and I have those my root here, as I explained with that singleton. So I guess everyone knows what to do when we would like to assign this list to the list of books here. We can do two things. It is here final, because as I said, since we keep pointers, you can help MicroStream by using final collections, especially for collections. It is nice, of course, so that you can help the system there. So what can I do? I can clear. I might have already books. I want to get rid of them, and I add the entire list. So that's at all the list of all those mock-up data. But now comes the question, what do I need to store? I need to give here an object. If I would use the root, if someone is willing to try to answer if this would store my data, yes or no? If I store the root, will my data be stored? Someone who wants to unmute himself or types it in the chat. You have only yes and no, so you have, if you're gambling, you have 50% of chance.
No.
No one who would want to place a bet on if it's stored or not. Remember what I said? By default, you have the lazy storer. You give a reference to this object, data root. And the only thing that MicroStream finds there is this pointer to books. Actually, it's a list, but that is not changed. So it stops there. So it does not look into the array list itself. So meaning that using this line will store nothing at all. And the title there of the slide, you should try to remember that and try to see how that fits into your code, namely store what is changed. What is changed? Where did we do any kind of change to which object? Well, we called two methods on an object. So probably this get books is changed. So this one will give what we want. Namely, this is the changed object. This is the first root of the subroot. I will call it the subroot. And this first object that we give to the lazy storer, you will see that it is changed because in this case, okay, the first time clear does nothing, but it sees that the items in that list are different, at least some of them. In this case, all of them are different. So that means he stores them. He also finds out and that those books are new, etc., and he stores everything. So let me run now, because that makes more sense if I run it this time. And as I said, I'm just trying to keep it easy and not using too much nice stuff that we have available of running those kind of things within the IDE or how to reload and those kind of things. So if we then ask the books, what's the URL? So it is just data books. I have here something open, curl localhost 8080 books. Probably I will need to switch to the browser in a moment. First of all, it is empty. It's not empty because I still have data there. Whoops. It was from the previous run, so I have already my books. Okay, when I create them, of course, then will books create. Then my books are successfully created, but of course, yeah, it's the same list, and you don't see the difference, of course. But you can try it for yourself. You will see that actually this only stores what you want. Maybe a little query. How do we get all the books that starts where the title starts with a letter A? So that's Stream API that we mentioned already. So we stream them, we filter them where each book get name starts with the letter A, and we return them to a list, not to a set. Yeah, so that's an example of how you can create a query. Okay, now we have our books. Remember, we have that other one, get instance, our database, not get instance, it is get root. We have here, okay, we don't take in the parameters from the URL, and it's even a get, but you get the ID, the user posts data about a new entity. So this new book needs to be added to the list. So from a Java point of view, that's easy to do, ignoring the fact if I need to check if it already exists, etc. I'm adding the book. Storing it. Someone who wants to try it this time, what do I need to put here as parameter? Store what is changed. So what is changed? Root get books, indeed. Thank you, Daniel. Same principle. What was the method where on which object was changed? On which object did we execute this add method? On this one, so we have to change that one. I'm going to skip a few. They are all there in the solution, so you can look for it for yourself. Same thing here. You can even copy paste a lot of it. This will clear out everything from the database, at least from the books, but that's the entire database. We have nothing else. So we remove all the books, clear on books. So root, get books, everything is gone. Also the authors, of course, because the authors are only linked through the books. So we are throwing away the parent, so the child is also gone. Yeah, this one, for that one, I should have here created a single one. So I have here created a book with a certain ISBN number. So suppose that I want to update the timestamp. I made a mistake on the timestamp. So I want to update the timestamp of that book that I have there. So root, get books, stream, filter, and then book that ISBN number, and I'm going to do it more or less properly. So I'm doing it like this. If it's equals, then I want to have it filtered. Filter is not closed. Find any. tomorrow I'm going to discuss a bit find any and find first for those that are maybe not familiar with the difference between find any and find first and the implications on that. So if I did found it, normally should make this, there is a way of using a lambda there, but again, just ignoring that. So I have my book here and I can update the release date. I'm going to update it to this very moment. And that's always nice on an IDE. Well, that's the lambda way of doing it. Again, storage manager. I need to store something. What do I need to store? The book, the entire list, or what do I need to store? A book. Well, a lot of people will, at first you will do this and it will not work. Why it will not work? Well, that's your optional. That's not your book itself. So you need to do something like this. And the reason why I type it like, and I made this example like this is because in the beginning, I made also that mistake saying, I do store of this book, and then actually it does not store the book because I'm storing the optional object. But indeed, as someone mentioned, I could do it in the lambda here, and I could then put multiple and use, and I'm going to reformat it because otherwise it is a horrible thing. I can store here then the value, yes. And then it is clear again. What did I change? I used this set, so that's clearly a change on this object. So just use this object in the store and you're fine. Okay, all the books which start with the letter A, for some reason, we want to give 5% discount. Update multiple here. And this will be now something different than all the rest. So, and this is something important also. So this is an important case. So I'm going to just assign it to books. So this is the list with all the books with letter A. And then for each, I'm going to do it differently. I'm going to do it in a for loop first. I'm going to set the new price is the big decimal bin parameter, big decimal. Of the value of big decimal. I should okay. I have a double. Sorry, I was a bit confused. So I give 5% off. So I'm going to multiply it at the original price book price, like this. I changed this one so I could do something. I can store the book. And it gives 5% discount. But there is a problem with this code. What happens? Okay, I don't know how many, let's say that I have 50 books with the letter A. I'm start processing them. and after number 33, my system crashes. What is stored to the storage? After this store method is performed here, we have certainty that the data is already in the primary storage. I say primary because tomorrow I'm going to tell about the backup storage, and there it is a little bit different, but we are certain that it is in the primary storage. So if the system crashes after 33 updates, and those will already be done and will already be stored externally, binary, serialized, all done. So when I start up again, some of the records are updated, some of them are not updated, which is, at least to say, annoying. If you do something, you probably don't change the price like I do, so you have a track of old prices and new prices, etc., and blah blah blah. But the idea of what I want to mention here is that you have one work of units, to say it in the more or less in the database terms, which are partially executed, and yeah, the rest not, is not a good thing. We want to have everything going or not going at all, especially to the external system. How can we do that? We can do that by asking for a storer specific. The lazy storer is fine here. We don't need the eager storing. But instead of using this storage manager store, we can use the storer, lazy storer in this case, and ask for the store method on that one. And then something that we, again, should not forget, which I also made a mistake in the beginning, is that at the end we do a commit. So based on this word, you can already imagine what's happening. This store method on the lazy or the eager storer, both are working in the same way, is not exactly the same store method than on the storage manager. Because here it takes the object, creates a binary representation of it, but does not write it yet to the file system, in our case, the storage in general. It is kept, I would say, in memory, but it's not the JVM heap, it is the off-heap memory of your JVM. Only when you do this commit message, this commit method, then all the information gathered by all the binary data gathered by the storer are written to that external storage. So if you have the same situation where you have 50 books, after number 33 there is a crash, nothing is stored to the external storage, which is, in terms of that transaction work of uniting, much nicer. Any questions about it? Because this is an important principle. So if you know it, you can benefit from that knowledge a lot when you are writing some methods within your application with MicroStream. For those that took attention to my explanation, I mentioned off-heap storage. So if you're running your application within a container, Docker container or whatever, make sure that you don't set your heap size too large in relation to your container memory. Because this is stored, these binaries, okay, for this book, these books, that will not be a lot of data, but it can be, of course, depending on your use case. These data are stored outside of your heap. So if you say, which probably nowadays much less than in the beginning, but let's say 5 years ago, people said, oh yeah, let's create our JVM heap as large as the memory that we are assigning to our container. But that means that our JVM heap can grow too large, and that you get some kind of out of memory on your JVM process. So also here, make sure that you keep enough space for this kind of operation. The JVM itself requires some memory storage additional to the heap itself, but this had so MicroStream also, not only this one, but also the here the storage manager store. Yeah, first it does the entire processing to the binary format. He puts that in direct memory buffers, which means off heap, and then he flushes those things to the file system. So make sure that you reserve some space in your process for these kind of operations. And this way, they're using the storer, the lazy or the eager, and this commit can make sure that you get the all or nothing one. Question in the chat: is there a command accepting multiple objects that should be stored that could also have eager or lazy transaction mode? So you mean that you have here, I'm going to use this, that you have here multiple ones? I'm going to use small letters object 2. Do you mean that you have here multiple objects that you want to submit? Yeah, no. So no, that's not possible. The store method name takes only one parameter. If you want to have something like this, but you want to have the guarantee that it's the all or nothing one, then you need to use the same technique as here. Create a storer and then store them individually. No, there is also no store here. I have seen it somewhere. Store all. See? Do we have it here? Yeah. Okay, so rewind. Yes, it is possible, but you need to use store all. Store all is available on the storage manager and on the storer, because we made sure that everything is available. You see, store all is also available. Another question is, could you simply do a store of books, passing the list of books that have changed as a list? Okay, so you mean something like this. I can do change books on the books list, and then store me these books. Actually, in this case, but I should try it out, I think it works. But it is not really recommended. And I'm trying to explain why. What does this store books do? Well, it stores this list. And since that's this object is not known yet by MicroStream, it appears as to be a new one. Wait, what I'm going to say? No, again, reverb. So what I said, no, this will not work. And I will explain you why. For MicroStream, this one is a new object, which is, yeah, it's completely new. It does not, it has no knowledge about it. So it creates the binary representation and stores it in the binary format. But it assigns it a, yeah, maybe it is the word. So you see, you need to test it out, but I find it a bit tricky. So actually, this would store then this list as some objects hanging around outside of your object tree, because it is not part of your object tree. But since these books are references within your object graph, he will also store it, because yeah, that list was new, and then that means that the items within that list are also considered new, so it will store it. But since the references are already in the binary storage, they will actually be seen later on as an update to the previous version. So yes, this works in this case. Probably in some other cases where you have more complex things, it might not work. But I find it a bit tricky because, as I mentioned, this object is hanging outside of your actual object tree, hanging outside of your actual database. MicroStream will store that in the binary format, but will never, ever read that again. I'm going to tell tomorrow a bit about householding processes. After a while, it seizes that there is some kind of orphan in the binary storage and will remove it. So it will get cleaned up, but you see what I mean? It feels a bit weird of doing it this way, but actually it's a good thing. I will try it tomorrow and report back, but actually this could work in this case. There is a mention of you could use a store all. Yeah, you store all. It can use also an iterable. In that case, I think it's a bit better because you don't have that books object itself. Yeah, but I'll make a note. And that's a very nice remark about using it. But if you're very conscious about how your object tree looks like and what points to what and what you're storing, and you know the internals of MicroStream, how that works, as I said, because every object gets also assigned a unique object ID, which is stored in that binary format. So by knowing all those things, you can figure out how it works. But again, sometimes it is easier to, at least in the beginning, try to keep it simple. Yeah. There is a mention here, the lazy storer. That person said, well, I can use lazy storer, get all of books. Yes, you can do. You can do that. But don't forget then to use the commit. Because the store, if you're asking for a specific storer, lazy or eager one, they are not, changes are the data are not committed by default. So don't forget that. You don't need to use the commit. You don't have it in on the storage manager, but you have a commit on the storer, and you should not forget to use that one. First, I'm going to give the link to that person that said I was a bit late at the beginning. So this is the link. Why can I not? Okay, type chat in here. So then he can also catch up. That was one thing. Okay, then I'm trying. Okay, someone else typed it in, copied in. Thank you, Lionel. I did not see it. I just saw passing the message. Let's catch up with the messages, with the chat messages. Okay, so we did the store all. It takes an iterable, so you can do this indeed. Watch out if you are doing the lazy storer, and then yeah, that is the remark. Storing an object that is going to be orphaned should be at least give a warning, just so that you could you know that you should use store all. Well, actually, I also thought about it, but well, that warning would appear in the log file at the runtime. I'm not sure if you're willing to search the log file for this warning and try to trace back, or we should give some kind of stack trace or small statements where it happened to find out where you stored a orphaned object. So yes, I was also thinking about it, but on the other hand, it might be quite cumbersome to try to trace it back. And as I said, it will be handled correctly. It will be cleaned out after a while, so there is no real harm done, except that you have temporarily used more storage than is actually needed. Question would be awesome to something like a callback for store all. A callback in what sense? Because I'm not following that question. So I call back on what was the results, or what? Okay, the callback and hold the commit call. Yeah, that's an option, that this store all it returns void, so that this returns something that you can do a commit on. Actually, it would be itself. It would be the storer itself, because you can have multiple stores, as we have seen here, and then you do commits for all of them. So yeah, probably. And store is returning here already something, and that is the actual that object ID that I mentioned, that unique ID that each object is assigned when it's stored by MicroStream. Okay, good questions, good feedback. Thank you. Anything else? And then we have the time for the break. Maybe we can just see if it's something specific for the storer. Don't forget to commit. But I mentioned the off heap, then the native memory for containerized. Use as much as possible immutable objects like final lists, final maps, etc. If you have a new entry in a list, or you remove some entries in a list and store the list itself. Okay, I've given here you see the collection here. If you update some property in the POJO, store the POJO. And then we have exercise time. After a short 10 minutes break, because this one was longer, this afternoon here was longer than normal. So going to do a quick stop of like something like 10 minutes, and then I'll explain the exercise, and then you either can do it now, you don't have to do it, so it's also fine. But I will be here till the end of the training if there are any questions, and before we sign off, we make some arrangements for tomorrow then, of course. So I see you in 10 minutes. So we have seen the most important things today of MicroStream. The reason why MicroStream was started a few years ago, about 10 years ago, as at that point a reaction to some of the customers that the company had at that point, where it was sometimes stressful to have all that querying from external data. We have seen the configuration, we have seen some data model considerations that you need to be aware of, that denormalization aspect, what I talked about, and that indexing thing with maps, for instance. And we have seen an important rule, store what is changed, so that you have the data externally for the case that your program restarts and that you don't lose any data. We only have one thing for today left, which is an exercise of everything that we have seen. But before I explain that a bit, because you can drop off if you like. If you're not, as I mentioned, you don't need to do it. It's just if you want, if you have time and you want to play around with it. So some people in the past remarked that not everyone, or some people did not receive a mail for tomorrow. So it is the same link, so the same Zoom meeting tomorrow. So we start at the same time tomorrow. So you can join again on that meeting for the second day. And then we start by discussing this exercise, and then we continue with what was on the agenda, the smaller things which are nonetheless also important as a basic understanding of MicroStream. The exercise there is already a solution, so either you can study that solution that I've provided here, that exercise directory, but the idea is described here in this Markdown document. So where you have a quite simple data model, where you have a company, actually a car company, which has cars and brands, and the thing that we explained during the data model discussion. And yeah, the endpoints that you could develop are a list, the classic CRUD thing. I'll listing, getting an individual car, deleting one, inserting one, and the same for the brand, except that you can delete the brand. Actually, for those who have time and are willing to do that, then of course you can delete the brand if there are no cars assigned to it. So that's about it. You can use those templates, but I mentioned Spring Boot, Quarkus Micronauts, and Payara Micro are provided, but basically with that simple singleton pattern what I showed you, you can, I think, use it in any kind of framework. I'm staying here online until, so for the next 40 minutes. So if there are people that are trying it and have questions, feel free to ask them. I will stay here. But as I mentioned, you can do it offline, that exercise. You can just, probably for a lot of people, just sit and relax for the rest of the day, because it's already, it was already more than enough for today. So it's up to you what you do, but I hope that we see you back tomorrow at the same time than today for the second time. And of course, if you have questions, please, any kind of questions also outside of that exercise, you can also put that in the chat or ask me.